Welcome to, I still haven't figured out if it's day 3 or day 4. I guess we'll follow the agenda there and call it day 3. We'll just take you through a few things. As you can see here, we have an abbreviated day. We're really committed to getting everybody out of here by 12:30, as indicated here. So we're going to continue on in our first session in the vein of delving a little more deeply into thinking about impacts and stakeholder perspectives. I think there'll be a little more of a theme of sort of cascading risks, maybe further engagement in some of the sort of policy questions, adaptation pathways in the context of correlated risk in this session we're going to have now. And we are going to have time for the listed discussion in that session. That's the plan anyway, as long as the talks don't run long. So we've recovered the lost time yesterday, and so we'll be able to go back to the normal timing for that first session. Then we are going to take a 15-minute break, which is for coffee, which is going to include a group photo just outside. And then we're going to come back and we will sort of do the report back, broader discussion about our sort of takeaways for the workshop, general reflections, and think a little bit about key sort of tangible next steps. Colin will say a little more about that in a minute. And then there'll be a couple other items that we'll sort of announce at that time. An award, for example, for early career poster and early career oral presentation. We're excited to announce those in a few hours as well. Okay, so I wanted to kind of quickly, again, towards this sort of idea of reinforcing our thinking during this session about some of these sort of big picture questions. Just quickly, a few takeaways for me from yesterday. If we sort of think about the maybe more climate-oriented talks, in some sense of the first two sections yesterday, some things I found myself thinking about are how is basic predictability going to change with climate change? As we're sort of thinking about some of these emerging correlated extremes, what are some of the overall emerging patterns, for example, in the background flow that could be changing our ability to predict these things just as we're learning more about correlated extremes? Just to sort of randomly grab an example, are we seeing changes in dynamics at high latitudes, Greenland high, something like that? Is in this non-stationary environment, how do we sort of keep up with shifting baselines of various types? I think as well as a more general comment about, as we heard from folks yesterday, they need to think about these timescales like subseasonal in our predictions. Another kind of general comment, I think this workshop, as someone who's getting more interested in heat waves, for example, and drought, to me this workshop has really illuminated this sort of great opportunity for the dynamics contributions that we've heard a lot about, the large-scale features, to engage deeply in sort of thinking about process-level feedbacks with some of the lower boundary condition dimensions. So thinking about things like soil moisture, SST anomalies. How can those communities sort of work together to explore the inevitable couplings between those systems? Role of correlated extreme events, including emerging correlated extreme events. Are there going to be some correlated extremes in the future for some of these regions that we haven't seen yet? Are there some regions, for example, that are close to a threshold of SST that may increase the probability of weak tropical cyclones in places where we don't currently think about tropical cyclones as being a major risk? Southern California might be an example of that. And so how can some of those correlated extremes and shifting baselines potentially lead to shifts in the mean state, sort of become drivers for some of the mean state changes that we've been thinking about in the climate world and beyond, sort of transitioning to the impacts talks, as we heard about vulnerability yesterday in the afternoon session and how a stressor of any type, including a correlated stressor, can push a system into a whole new state. Think, for example, about some of the long-term impacts we heard about in Somalia yesterday. Another thing that came out to me, thinking a little more about impacts, the nuances of sequence mattering. Thinking, for example, about Jane's presentation. It's not just the sort of summary statistics of mean and variance, but the actual timeline and the sequence of when things can happen is important. Also, the sequence, where we are sort of within the seasonal cycle can be really important for a lot of these impacts. As the mean shifts, it can manifest as a shift in seasonality. I think seasonality is another component that we've sort of talked around in some ways, but that's sort of behind a lot of what we're thinking about. And notions of sort of, is the weather getting wackier? Is some things that might appear at first glance to be a change in wackiness actually just a result of modulation and shifting of the mean and the way some systems are responding. Just one sort of example, possible example from a conversation I had with someone in the hallway yesterday, talking to me about how the incredibly wet conditions in the northern plains this season could in some ways precondition us for real drought vulnerability in some crops later in the year. There's so much water that a lot of the root crops just aren't going to build very, I'm showing my lack of ag knowledge here, but they're not going to build very deep roots. So if there's just sort of a typical sort of flash drying out, later in the season, those crops are going to be less able to deal with that because of what's been experienced so far. We can think of other examples related to temperature, things like chill hours. We heard a little bit yesterday about how frost damage can be greater if crops are sort of deceived, if you will, into thinking that the last freeze has happened earlier than it really has. We also were reminded about multiple causality, tipping points, all the different ways that climate can interact with various sectors, all the ways that different sectors interact, right? We heard from Jeremy Hess, we heard from Alex about the dangers of solely thinking about how climate touches the most obvious aspects of the food system. It touches all aspects of the food system, just as Jeremy Hess told us the importance of having an integrated approach to health that thinks about much more than just the direct ways that a climate variable impacts the human body. Thinking about, for example, the stresses that extreme events put on vulnerable populations. We heard a lot about cascading impacts, right? The 17 billion in insured losses that in Thailand with the floods. We heard about the mortality impacts from Jeremy of that one producer of the saline bags going offline, how that had cascading effects. And shifting a little more maybe to the policy sort of realm, we heard about some of the sort of missing voices here and maybe more broadly in the community. We heard about gentrification and how sort of those with the most power are able to sort of deal with extremes or correlated extremes better than those who may have, often better than those who may have less of a voice. We heard about how correlated extremes can inform humanitarian aid, can lead to maybe modifying heat warning systems in ways that capture what's happened in the prior days, for example. And I think overall we learned that if we meet decision makers at their decision points, thinking about James Dunn's talk, how he sort of cast that climate information in a decision space that water resource managers are used to working in, that'll be the key to sort of helping this correlated extremes work spread and have more impact. Building that buy-in, which helps with actually getting implementation of some of what we're learning, and thinking about how to communicate in ways that each of those stakeholder groups are used to sort of communicating. There was also, I think, a thread, just to close, that some sectors are already starting to think about correlated extremes. As we know, this isn't a novel idea. We heard that from Alex. We heard that from Jeremy as well, at least at kind of a linear level. I mean, maybe not thinking about all the potential for surprises, but they're starting to think about it. But policy's not being implemented, right? We're just at sort of a stress testing stage. I think Jeremy said that they actually know in a lot of ways some of the things to maybe implement at a trauma center, but it's a very different thing to actually say, let's get them implemented. So just a few reflections, really looking forward to sort of the deeper feedback that we'll hear from the last 2 days during the breakouts. And again, as we're listening to the talks this morning, please continue as you have been to collect your own reflections. There'll be a lot of time to talk about that. I should say that the report backs, when they happen after our breakout, are going to be very short, just 2 or 3 minutes, a few key takeaways. I think in most cases it'll be the steering group member who led the discussion will do that report back, but in a few instances, it might be someone else. But after that, there's going to be plenty of time for everybody to weigh in on these questions, other questions, really just sort of anything you want to talk about during that final session. So with that, I'm going to turn it over to Alex Ruane, our chair, for this morning's session. Oh, I'm sorry.
All right, so I was just going to make one more comment, which is I sent a tweet about this, but I don't know how many people are following. It seems like maybe many of you, but in any case, if you want to share something in terms of sort of a future collaboration opportunity or sort of general interest research platform or something that you think would be relevant to everybody, and you have a slide about it, please send it to me so that I can kind of put them together in an organized way for later today. If it's online or something, you can obviously just do that instead. And then the other thing was, I was just going to riff off of Bradley for a second, which is that I think this last session will really be sort of sectoral things, but people and topics that are thinking about correlated extremes sort of already, rather than more the potential to have correlated impacts. So we'll hear from several people, 6 different people who all have sort of correlated extremes expertise. And with that, I will plug in the clicker and bring up Alex.
All right. Good morning, everybody. I'm glad to see you all here. We have a very interesting and a little bit different session this morning, focusing on systemic risk. So we're going to be challenging everybody to think about the limits of their own systems that they're looking at, and understanding that everybody here does have a certain perspective that they're looking at, and that there are influences that come from the outside that many times we just assume are not changing, but in some cases those are some of the most interesting interactions. So the session is called Systemic Risk, Identification, Response, and Societal Feedbacks, and I think we should jump right in. One thing just to note, at 10 o'clock we have a remote presentation that's going to come over the Zoom link. So we are going to somewhat force that time slot into our overall conversation here. So we'll just have to make sure the timekeeping works to make that all possible. So with that, I'd like to invite Marla Schwartz-Porabani up to talk about some of the interactions with insurance and reinsurance.
Thank you. So hi, everyone. My name is Marla Schwartz-Porabani. I'm part of Swiss Re, and I'll explain a little bit about reinsurance in a second and try to give some flavor about how the reinsurance industry thinks about correlated extremes and why some of the topics discussed at workshops like these are really key to reinsurance being used as a financial instrument to transfer risk from individuals or from businesses to larger institutions. So, and I meant to say this at the beginning, but all of the views that I express here are not meant to be used for any kind of financial decision-making or insurance decision-making. They're merely meant for educational purposes, and you'll see the disclaimer at the end. So before I jump in to discuss reinsurance, I think the term can be a little bit confusing. Some people think it means to insure something again when they hear the prefix re. I thought I'd kind of just explain what reinsurance is. It's essentially insurance for insurance companies, so in some ways it is to insure something again. And what this looks like in practice is you have a group of insured, it could be people, it could be cars, it could be houses. They purchase some insurance from a primary insurer, that's the circle in the middle. And then as a second form of risk transfer, an insurance company will then cede some of that risk off to a reinsurance company. And insurance structures have been around for a long time as a means of risk transfer, with the notion that many people get together who are exposed to some risk. They each pay some premium, and the hope is that just a couple people in that risk pool will experience a loss. You know, their house burns down or they get sick in a given year, but the premiums that are collected by everyone will go toward paying for the losses that are experienced by just a few people. And that system seems to work fine until everyone is impacted at once, which is what you start to see with really extreme weather events. And so when you think about the role of reinsurance, this is really to protect people against and to protect insurers against extreme weather events. So reinsurers are pooling risks on gigantic global scales and across many different lines of insurance. So it could be property insurance, casualty, life and health, et cetera. And again, we're looking for the kinds of risks that impact many people. So natural hazards such as tropical cyclone, earthquake, flood, wildfire, winter storm, drought, et cetera. This does extend into like terrorism, cyber attacks, or pandemics, but I won't get into that today. So as one of the world's largest reinsurers, assessing natural hazard risk and extreme event risk is really a core part of Swiss Re's business. And one of the key principles of insurance is diversification, right? You don't want an entire risk pool of people of people with poor health or of people that are prone to get into car accidents. You want to diversify your risk pool, but one of the complications of this is certainly risk correlation, where you have many people affected by the same peril, or many people that are bad drivers, if you want to think of it in a different sense. So when when everyone here is talking about correlated extremes, this again is just one kind of wrench in the complicated world of reinsurance and natural hazard risk assessment. And not to harp too much on this, because I know Steve talked about this yesterday, we discussed trends in global insured losses. So what I've shown here is from 1970 to 2018, and you'll see the dark blue is looking at earthquake, tsunami. We're not going to talk about that today. The light blue is the weather-related catastrophes. That will be the focus. And then the yellow is man-made disasters like terrorism, cyber attacks, explosions, et cetera. And what you can see, both summed across these three categories and within just the weather-related catastrophes alone, a large increase in insured losses over time. This is driven by a number of factors, including population growth, the concentrations of populations and their properties in exposed areas, namely coastal areas, increasing values. People want more stuff and more expensive stuff now than they did 50 years ago. And underlying that is also the changing hazards. So climate change, correlated extremes, sea level rise, et cetera. And again, these are just the insured losses. Steve hit on yesterday about the protection gap, so the difference between economic losses and insured losses. If you put that on here, it'd probably double all of these bars. So the protection gap is somewhere between 40 to 50% on a given year, varies strongly by country. But again, I'll just talk today about insured losses because that's most of the data that we are privy to from clients. And I will note that 2018 was the fourth costliest insured loss year on record. And that was at $85 billion. And the economic loss from 2018 was $165 billion. So again, you see that roughly 50% protection gap that exists either because people aren't aware of their risks, they can't afford insurance, they don't live in markets that have a strong insurance culture, or a number of other reasons. But maybe we can just look at some of the weather-related losses from 2018 and what contributed to those types of losses. First of all, there were a number of small to mid-size events. And when I say in terms of size, I mean both in terms of the spatial extent of an event footprint as well as the dollar economic or insured loss of the event. So for example, wildfires in California, severe convective storms across the world, flooding and typhoons in Japan, or some of the hurricanes in the US in 2018 that seem to really just impact individual states. Many of these losses came from perils that haven't, like historically or traditionally, been associated with very high severe losses. So for example, in California, this has been discussed many times, the Camp Fire had about a $12 billion insured loss. In Japan, we saw floods with insured losses much greater than we had seen in previous years. And we've also seen really a rise in water and wind-related perils, which again goes back to conversations about changing exposure in coastal areas and again, this discussion on the role and impact of climate change on natural hazards. So the 2018 losses were really just from a number of these small to mid-size events that are typically not ones to produce high losses, and typically few and far between in terms of insured losses. And I bring this up kind of as a segue to discuss how the insurance industry typically thinks about natural hazard risk assessment. And there's this traditional view of thinking about primary versus secondary perils, where primary perils are much larger events in terms of their spatial footprint and damage. So tropical cyclone wind, earthquake, et cetera, they can affect entire countries, multiple states, and they're really known for large, severe losses across a wide region. And these are quite well modeled by reinsurers, and they have been for a long time. Secondary perils, on the other hand, and I would caution you not to be fooled by the term secondary, are ones that kind of don't fit into the primary peril bucket, either because they differ in size, or they haven't traditionally been large loss events, or they happen with much greater frequency than something like an earthquake or a hurricane. So these can be secondary effects of primary perils. So you can almost think of these as multivariate extremes. So that could be storm surge or rainfall that's associated with tropical cyclones. It could be, if you're talking about earthquakes, liquefaction, tsunami, or volcanoes, fire following the earthquake. And these secondary effects aren't usually well captured when just looking at primary perils, but historically the primary perils were the main cause of damage, so we kind of ignored many of the secondary effects. Secondary perils can also take the shape of high-frequency perils that produce rather low damage footprints in terms of lost dollars on an individual event, but they occur with relatively high frequency compared to tropical cyclones or earthquakes, for example. So these could be floods, severe convective storms, wildfire, drought, snow or ice, etc. And unfortunately, from a reinsurer or insurer point of view, we haven't had a good or robust or efficient modeling perspective to really look at some of these perils over time, and that's because they're starting to emerge. They impact many different places anywhere, really. You can have flooding outside of coastal areas due to torrential rainfall, far from floodplains, and they can also have a strong human component, for example, triggering wildfires, decisions by water makers about when to release water, etc. And I'll just highlight here, not harping on this too much, that in recent years, as I said, not to be fooled by secondary perils, these secondary perils are ones that are slowly creeping into a large component of insured and economic loss numbers. So in 2017 and 2018, we've seen those secondary perils accounting for about 50% of the losses. And this trend has been seen in the last 50 years or so. Secondary peril losses are increasing. There's still a protection gap associated with secondary perils, but overall losses associated with wildfire, tropical cyclone wind, surge, and severe convective storms are increasing. And so I bring this up to also mention that while there aren't the best risk assessment tools to look at these perils, the types of insight that comes out of workshops and the work that goes into conferences like this is exactly what we need for this kind of risk assessment. So in terms of giving some flavor of why this kind of research matters, it's exactly for this purpose. And when you think of insurance as a key financial instrument to allow people to rebuild and recover following events, that's exactly where this data is going into. And I know the time is up, but I'll quickly just mention here that to address questions about secondary perils, which often, again, are these multivariate extremes or sequential events, Swiss Re has developed various insurance solutions to specifically address this, and many of the risk assessment frameworks for these secondary perils comes directly from a lot of the great work that you guys are doing. So we have a wildfire recovery solution that was recently launched. There's a new product for China that is getting at questions about damage from heavy rainfall and mudslides. Swiss Re has also been the primary insurer for the Caribbean Catastrophe Risk Insurance Facility, which historically just covered tropical cyclone wind, but is now also covering excess rainfall from tropical cyclone. And then for the first time, I think a haze insurance solution has launched in Singapore and also in other places in Southeast Asia, based off of pollutant indices to get at some of the insured and economic losses associated with haze that might impact, health or tourism or transportation or education. I'll skip over this in the interest of time, but I think the takeaways are that multivariate, concurrent, and sequential extremes will only compound the damages both to people and property that we see in extreme events. Extreme events in recent years suggest that secondary perils really demand a lot more attention that they historically have gotten, and maybe even more resources than primary perils, which are quite well understood at this point. And at the core of this is really a need to review some of the underlying frequency and severity assumptions about these and the correlation within these perils. And I'll just kind of leave this up here at the bottom, but again, just hitting on this point of collaboration and communication between the private sector and academia and the public sector. I think sometimes the private sector industry is, I don't want to say vilified by academia, but there's this perception that we have all of this proprietary data and we don't want to communicate and we just want to make money off of what you're doing or something like that. But at the end of the day, insurance is meant to protect people and allow them to get back off their feet. So Swiss Re is very much open to collaboration with folks in academia, and we're the door is open if you have ideas on ways to, give us a better sense of risk assessment or help us create new insurance products to help people. So I will end there. Thanks.
We have time for a question. Yes, please.
Yeah, it can be very hard to tease out the exact contribution of, is it the exposure change or the hazard change in terms of secondary perils? And it really depends on the peril, on the region. If you look at wildfire in California, for example, in recent events, depending on which one you're looking at, sometimes it is due to exposure changes of people, building in the wildland-urban interface and more housing units and businesses there, but other times there, very much is that climate signal of just increased fuel loads and drier soils, and so the short answer is it's hard to tease it out, and I'm not sure that's necessarily a focus that we have right now, because at the end of the day, regardless of which one is contributing to it, it's still a problem in terms of impacting people and their properties. So there's a little bit of a different lens with which, reinsurers approach questions like that.
All right, thank you so much. I'd actually suggest we get the lights back on a little bit. I don't know if they just... Thank you. That's fine. All right, so at this point, let's get David up here. Our next talk is by David Carrozza. Let me pull it up for you.
Morning, thank you. I'm a postdoctoral fellow at the University of Quebec in Montreal. I work in the math department. My supervisor is an actuary, so we're doing a lot of work to try and integrate knowledge from atmospheric science into actuarial sciences. I'd like to thank our sponsors, the Natural Sciences and Engineering Research Council of Canada, and the MyTax Accelerate program, which allowed us to develop a partnership with AXA Excel. And their scientific team to work on spatial diversification. I'd like to thank Tom Philp of XXL and Manuel Grenier, who's now a master's student in our group. In their annual report summarizing 2015, Aon Benfield broke up the a number of atmospheric perils and then split them by ENSO phases. And so we can see here that more often they also found that, interestingly enough, that the La Nina years, so these are the ones in purple, were generally and statistically significantly more loss-causing in both economic and insured losses than El Nino years, and much more so than neutral years as well. So this showed that there was a lot of good preliminary evidence that ENSO impacts that we're becoming more and more familiar with can cascade through to economic and insured losses. And there's a lot of reasons for which some of these perils are more or less prominent based on structural considerations. But so we basically, to try and better explain and understand these sorts of features, we developed a modeling approach. Happy to go to speak after Marla. She gave an excellent introduction to diversification. And in reinsurance and in the insurance sectors, reinsurance is based on the expectation of spatial diversification. So essentially, a reinsurer, a large insurer, will have a portfolio of assets that they're insuring, and they sort of to decrease the risk of that portfolio, to increase diversification. One common approach is to diversify spatially. So essentially, start to sell business in a place that's far away from where your current exposure is, and hope that they're not that well correlated, to reduce the diversifiable part of our portfolio. But there are a lot of external drivers and structural aspects that can hamper this, or even in some cases make it impossible. Climate oscillations, for one, as we've learned more and more over the past few days, can cause difficulties in this. They create organization in the climate system, and hence increase dependence and create correlations and anti-correlations on a variety of spatial and temporal timescales that affect potential for diversification. Climate change is also expected to have important impacts on the distribution of extreme events, spatially and temporally. And also, importantly, the concentration of population and wealth can make it, in some cases, incredibly difficult to diversify a portfolio that is too highly concentrated in heavily wealthy and risky locations. So to study this formally, we've been working on a modeling framework whose objective is to assess the extent to which reinsurers can diversify catastrophic risk. We're focusing on atmospheric perils across space, time, and peril. I mostly focus on space for the time being. And given the natural climate oscillations, we're focusing on interannual climate variability and the present structure of population and wealth. So after a fair bit of discussion, we decided to go with to adopt a multi-peril stochastic event set approach, essentially forcing, in a very much a top-down way, multiple perils. For the moment, just flood, but ultimately more. At least flood and tropical cyclone, to force multiple perils with coherent climate forcing. Right. That's what I mean. So in detail, focusing on flood, there is, at least in the last decade, an increasing amount of work, very exciting developments in hydrological and river routing models that have been used to model flood and focus on it going all the way to impacts on people and property at the global scale. It's been done, and some of these models have been applied to they were looking at the role of interannual climate variability, mostly ENSO, and climate change in particular as well. But the challenge with these types of approaches is they don't allow for a large number of trajectories to be done. There's not enough initializations of the climate models. And most risk management type approaches, at least on the financial side, require large samples to be able to calculate with confidence certain risk measures. The other reason, so basically to simplify those types of models, we take a sort of a more aggregated approach, focusing on individual catchments, which is a larger scale than some of these high-resolution models will work at. I think we're further justified in doing that because for numerous reinsurance applications, detailed information of the actual spatial location of the properties being insured are often not even known to the insurer. So this is a schematic of our flood model. So we start with a climate forcing. We've taken, we're very lucky to have the NCAR CSM large ensembles. It's an ensemble of 40 initializations of essentially 1920 to 2100. We take the present day and use that to force hydrological model and river routing statistical learning model. And then we use that model to calculate and determine which basins are affected and which and how much, what fraction of the surface area in each of those basins is affected. And then we can look at GDP and the population affected as our exposures. Right. So these are a few slides on how I constructed the database. So we took the hydrosheds database from level 5, resulting in which consists of 4,000 over 4,700 basins at the global scale, and then we intersected that with the Dartmouth Flood Observatory of large flood events. These are polygons, so we took those from 1985 to 2017, about 4,500 events. These are, some are large, quite large polygons. They represent not the areas that were flooded, but more, they're bounding polygons for the areas that were affected, where they were displaced. Essentially, that gives more a sense of the spatial size of the storms that were affecting those areas, more so than the areas actually affected. So we do that spatial intersection, and because floods will impact more than one basin at a time, in doing that spatial intersection, we end up with roughly 36,000 what we call flood event basins. So for each of the basins, we then associate both climate and basin level factors. For climate, we just use temperature and precipitation, various indices of those, to look at the sequence of temperature and precipitation preceding each and every event. And we also look at basin factors, these that don't change in time, that are characteristic of the basins in question. Right, and then for the real construction of the database, there are essentially two statistical fits that are done. One is for the occurrence model, so whether there was a flood or not in a basin, and the response variable is just flood or no flood. And the covariates are the basin variables, and an annual representation of the climate variables over the water year that was in which the flood took place. Then the intensity variable is the area affected by the flood. So when doing the spatial intersection, we can actually calculate the area that was affected, and then we associate that to the basin for the actual climate variables and basin level variables during the event, in particular on the last day of the event. Again, just to be clear, the covariates are calculated for the basin that was affected. Right. On the estimation side, we use for both problems, both estimating frequency and intensity. We use a random forest. We use these because they allow for nonlinearities in the model and interactions without having to specify them a priori. There are numerous interactions that result in flood, interacting with the precipitation and temperature and basin level scale. Having to specify them a priori was a bit complicated, especially on the global scale where numerous types of floods can occur. So we take advantage of a more statistical learning type approach. Though the random forests are nice, I think I like them a lot from the scientific point of view because they're easier to understand. They're much more transparent and much more. I think you can actually go into the fundamentals of the model and see what interactions are taking place and discover why. On the output side, so these models will, on the occurrence side, will provide a probability of annual flood and the intensity of the predicted area affected. So this is the validation. I'll go over this quickly, but essentially we compared it to, for the occurrence, we compare the random forest very simply to the logistic regression, which is another model, kind of like it's a multiple linear regression for the problem where the response variable is either true or false, flood or not flood. And it works quite a bit better. We get much better true positive rates for the random forest. These are the green lines at the left and the right, and the precision is much better. That's the right is the key variable to look at. The precision tells us that when there was a flood, whether it was correctly detected or not. So this is a validation of intensity. So here we have simply, again, for out of sample variables, the area affected relative to that which was predicted by the model, and we get good R squareds and relatively low root mean squared errors. And so based on this, we can simulate. So the simulation approach was we take the 40 years from each of the NCAR large ensemble members, resulting in 1,600 years of physically coherent states of nature. And then we debias the climate model output and then feed those climate variables into the random forest for each of the basins for every year. And that gives us an annual flood probability, which I'll show some of those in a subsequent slide. We have a probability for every year in every basin, and that results in a large distribution of the variables of P. And then we sample from that distribution with a P, with the probability P, 625 for each basin. So 1,600 years times 625 gives us 1,000,000 years for each basin. If the sampling says that there's a flood in that year based on the event, then we calculate the intensity. Right. This is the first validation of the actual output from the model. So this is using the 1,000,000 years of output for each basin, and also at the same time a bit of a sanity check. We aggregate these. We were operating at hydrosheds level 5. We aggregate to a slightly larger physical watershed, levels 2 and 3, which we can see at the right. And just to give a sense of whether we're capturing the right amount. So, okay. So I'll go on. So so in the model we assume that the basins are independent of one another, in the sense that there's no physical structuring to them. This show, and that all the spatial dependence is in the climate model. So what this shows is that the probability of flood in any given year for subsequent years, each snapshot is 1 year and 1 year of flood. And we see that the probabilities are high among connected regions, even without an explicit connectedness in between them. So we have a natural contagion effect that can occur in the model, which is very promising. I'll skip this in the interest of time. What here we have is simply a map, and comparing to a sort of a map of ENSO precipitation anomalies. Essentially, from going back to the insurance perspective, so these are relative anomalies of the flood event rate in El Nino years relative to all years. What it shows is that if you have a large amount of property insured in these regions that are red, regardless of how far apart from one another they may be, there is the potential additional risk during El Nino years. So let's very quickly, let's pretend that we forgot, we weren't here the last 2 days, we've forgotten what ENSO is and what its teleconnections are. And we have a portfolio that's strongly based in the United States, and we'd like to diversify. We'd like to sell more business somewhere far away, and we pick southern South America. We see here, so this is output from a Shiny app that we've developed. On the left side is sort of the results from a simple portfolio based on just the United States, and a number of risk measures, sort of in blue here. This called the conditional tail expectation. Essentially what it says is that if we add South America, that's the slide at the right, the conditional tail expectation, this is a measure of the tail risk, actually increases. Not that much in this case. It's in fact quite small, but the portfolios here are very, very aggregated. So it's imagine perfect insurance in all of the United States, adding perfect insurance in all of South America, all of Southern South America, and you find that even with that amount of aggregation, still the risk increases. So then now we've learned about ENSO. We've gotten a little smarter. We realized that that South America was not the right choice. We instead picked Brazil, and we find in this case that the conditional tail expectation falls by about 6%. So the risk falls substantially given the size of already the very strong level of aggregation in the portfolios. So I'll just quickly conclude. So we built and validated a data-driven global flood model. We forced the model with output from a climate, a large ensemble, to generate a stochastic flood event set. And we've used some simple examples to illustrate that support for the hypothesis that climate oscillations such as ENSO can hinder or enhance spatial diversification for an insurer. Thank you.
We have time for a quick question while we transfer the next presentation up. Any questions? I'm curious, have you been able to look at things like the National Flood Insurance programs and whether these are matching up with what you have so far? Is that a data set that's available and usable for in the US, for example?
I think what that would be about. I think one challenge is exposure. We use more for academic purposes, population and GDP, raster data for the whole planet. That's not terribly precise, especially for at the catchment scale. But someone, I think, with the right modifications to the model, focusing on the United States, would benefit a lot from highly more detailed exposure data. But we haven't looked at the flood insurance program. But I think it's a way to sort of enhance the exposure distribution and to look at more particular, more specialized examples.
Any other questions? Well, we have the transfer. All right, looks like it's coming up. Thank you so much. All right, next up we have Virginia Iglesias from Colorado. And it looks like we're all set.
And we have a clicker now as well.
Morning. Now I'm going to shift gears and talk a bit about conservation. You may have noticed that in recent years, the objectives of conservation have shifted from those focused on preserving natural systems, historical or pristine landscapes, to those targeting resilience. But what do we mean in conservation by resilience? Ecologists will probably use a diagram like this to clarify the concept. Okay, resilience. Most ecologists will use a diagram like this to clarify the idea of resilience. So basically, we have a ball in a bowl. If we somehow move the ball, it will go up one side of the bowl, then go down and up the other side, and eventually settle at its most stable state. In conservation, this means that we are embracing change and disturbance. That is, we're letting the ball move to side, but without compromising the long-term structure and function of the system. That is, the ball needs to remain within the basin, within the cup. To me, this is a very appealing idea. However, it might be a little too vague, because if we think about it, what do a ball and an ecosystem have in common? As a matter of fact, what do we mean by the resilience on the ecosystem? An ecosystem is a theoretical construct, so we need something measurable about the ecosystem. It could be any process, could be any component, but it needs to be something that we can measure. So we might be talking about whales off the coast of Alaska. We might be talking about carbon storage in the soil of the forest. We might be talking about vegetation structure, but we need a parameter that we can actually measure. Once we have a parameter that we can measure, we can see the similarity with the ball. They both display a trajectory that can be tracked over time. Once that we have that trajectory, we can treat them as a dynamic system, apply equations from mathematical dynamics, and then we can assess whether the system is in equilibrium, and if so, if that equilibrium is stable or not. So let's look at an example. Here, the top panel, we have pollen data from Yellowstone National Park. What this is showing us is changes in pine abundance over the last 7,000 years. Here we have time on the y-axis from past at the top to present at the bottom. This is a convention in paleoecology that might look a little weird. So, as we can see, the system has been in stable equilibrium since forests got established in the Yellowstone Plateau approximately 7,000 years ago until present. So, what do we do with a system like this? Does it mean that the system is going to be in stable equilibrium forever? How can we make it change? Or basically, how do we get rid of this forest? Let me take you to the rainforests of northwestern Tasmania. Here again, left, we're looking at pollen data, and the right panel is showing us charcoal data. Charcoal is a proxy of fire activity. So pollen data are showing us that rainforests dominated the area for millennia. 4,000 years, however, a really big fire, a fire that according to charcoal data was at least 10 times larger than any fire at any other time, triggered a change in the ecosystem to eucalyptus woodlands. It is interesting to note that even though fire activity declined after that fire event, vegetation never recovered. So a landscape like the one that we see on the right was transformed into a landscape like the one that we see on the left by one fire event. And we can say that the landscape that we see today is a legacy of one extreme event that happened 4,000 years ago. Although when we see changes in ecosystem dynamics of this type, we're always seeing nonlinear responses to climate in this case, climate or disturbance in this case, it is not too surprising to see that an extreme event can trigger a shift in an ecosystem. That is, we have our bowl slowly and gently swinging from side to side of the bowl. And then all of a sudden, we kick it really hard. It's not too surprising to see that it's going to land in a different cup. Things can get a little bit more complicated, though. If we go to the southern Patagonian Andes in southern South America, we can learn that forests established after glaciers retreated approximately 9,000 years ago. After that, they prevailed in stable equilibria for 6,000 years, more or less. 2,000 years ago, ENSO got more intense. That is, it reached modern levels. For those of you who are not familiar with the climatology of southern South America, ENSO has a very little effect on both precipitation and temperature. However, that very slight change in precipitation variability allowed for more frequent fires. These fires killed trees. Fewer trees meant decreased evapotranspiration. That led to water saturation in the soil, which in turn resulted in more acidic soils, which prevented further establishment on trees. And this cycle kept going for now 2,000 years, and we can still see it in the landscape. So in this case, we're no longer talking about a cup, like in the previous case, but it's more like a gentle slope that goes from a forest like the one on the right to a bog and a young lake like the one we see on the right. And what is determining the slope of this landscape is the strength of the positive feedbacks that are triggering change. So this is a much more complicated case because we have a non-extreme event triggering a very strong response in an ecosystem. Now, if we consider that natural ecosystems are not a real thing, but that they are only a part of a system composed by social, ecological, and physical components, our new system of study becomes much more complex. So far, we've been seeing shifts in ecosystem triggered by drivers coming from the physical side of this diagram. Change, however, can be triggered and can happen at any of these subsystems. Let me tell you a story to show this. In 1880, an Italian ship arrived to Eastern Africa with cattle from India. Unfortunately, this cattle was infected with Rinderpest. Rinderpest is a virus that infects ungulates. This virus spread quite fast through sub-Saharan landscapes and reached Western Africa in 11 years. and in 16 years, it had already spread throughout the continent. This meant that lots of ungulates died. For numerous ecosystems on the continent, it meant that countless wildlife died. Because savannas, which are quite abundant in Africa, are very dependent on herbivores, the fact that we removed millions of animals from the system led to a shift from savanna to woodlands. On the social side of this equation, we can see that the death of ungulates meant basically death of cattle. This death was not only caused by the virus, but also by decreased grass, because our savannas had shifted and had turned into woodlands now. So Africa lost approximately 90% of its cattle. And this loss of cattle led to a change in social structure, pretty devastating effects in the economy, and death to starvation. In Ethiopia, for example, a third of the population died, and only 1/3 of the Maasai people survived this event. However, if we look further south, societies appear to have much less vulnerable to these pretty dramatic changes in both the economy and ecosystems. I do not have the data to tell you what happened there, where that vulnerability came from. But without meaning to extrapolate anything, I can take you somewhere else to show you what gave resilience to other communities that strongly depended on the land. These are the Anasazi in western United States. The Anasazi were probably one of the most emblematic societies prior to the arrival of Europeans in North America. They had enormous cities, buildings of up to 5 stories and 600 rooms, and in the Chaco Canyon, one of their most famous sites, population declined in a matter of years. That is, very large and active cities turned pretty much into ghost towns in 3 or 4 years. This decline in population has been attributed to a mega drought. But what do the data tell us? Well, here we're looking at a precipitation reconstruction from tree rings. These tree rings come from the same canyon that we're talking about. And as we can see, the Anasazi population collapse did happen during the mega drought. However, if we look back, we can see that their economy survived many other mega droughts. So what was special about this one? From the physical perspective, nothing. It was just another severe, multi-year drought. From the social and historical context, however, it was quite different. The Anasazi populations had been growing quite dramatically before this drought. And because of that, their cities, just like any other modern city, were not self-sustainable. That means that they had to grow their food in marginal areas. These marginal areas were okay and worked fine during average and humid years. However, during drought, they could not produce enough food to sustain the human populations that were growing. This lack of food led to starvation of some people, but also to social inequality. And this, of course, triggered some social and political instability and led to massive migrations. So I would like to finish by reminding us all that we're dealing with very complex and interconnected systems. Change can start at any of these systems and may or may not propagate into another ones. Extreme events can trigger dramatic change, but it's not only extremes, also average events can trigger positive feedbacks that lead to regime shifts. In addition to this, we've seen that both vulnerability and resilience change over time. They are not static, they depend on the dynamics of the system. So this means that the fact that a system has been resilient to a certain event in the past, that not necessarily mean that that system is going to be resilient to the same type of event in the future. So to me, if we want to be efficient in conservation, we need to understand that the times of one-size-fits-all are over. And planning and strategies need to be designed considering the uniqueness of each ecosystem. Thanks.
Any questions? We're gonna, just by way of order, we're gonna go to the invited speaker next, the remote presentation, then circle back to,
After this, one more talk.
yeah, but is he ready at 10?
I told him.
Okay, so we will do Francisca next, sorry about that. Any questions? Yes, please.
Thank you. Thanks for your talk. I was wondering if you think, what kind of tools you think are the most appropriate to study this even more complex systems? You mentioned dynamical systems when we were talking about more on the ecological side, but as you start increasing the complexity by adding behavior of humans and stuff like that, how do you think the same tools apply, or do we need more tools to model these systems? Thank you.
Well, I think that there are plenty of tools for dynamic systems. However, I'm not a sociologist, but I'm pretty sure that they would not be enough, and we would probably need tools. We need to develop new tools. It hasn't been done. I really cannot answer your question, I'm afraid.
One more question? I'll take the prerogative. In your landscape and ball diagrams, I was trying to figure out all the dimensions there. I'm sure there's many variables there. But it strikes me in the theme of this workshop that maybe a secondary hazard or a second event could kind of push you into a mountain pass and into a new transformation. Be interesting maybe to think about what type of pathways there might be with multiple events.
Yeah, I think it's critical, and it's something that we can do with process-based models, we need to identify where the system is located along its trajectory. So independently of one extreme event triggering another one or being driven by the same factor or whatever the relationship might be between two extremes, if they are both affecting the same ecosystem, the net force is going to change, right? They could amplify or dampen the effects of each other. So definitely non-linearities.
All right, thank you so much. We're going to move on. So our next talk is by Francisca Gao. Let me pull this up.
Hello and good morning. I'm a postdoc at the International Institute of Applied Systems Analysis in Austria, and there I'm part of the Ecosystem Service and Management Group and the Risk Group. And I'm going to talk today about increasing risk of multiple breadbasket failure under 1.5 and 2 degree global warming. And to give you a little bit an understanding of what motivated me to do this work, I would like to start with an example. This has mentioned in the last days, it has been mentioned in the last days already, the drought in 2010 in Russia. It was the worst drought in a century. It was so bad that fields were burning and there were major drops in wheat production. And it was so severe that in August, Vladimir Putin announced an export ban for wheat. But this was not the only event that happened in 2010. It was also the driest year on record in southwestern Australia, where wheat accounts for 40% of the exports. And it also happened to be very wet during planting time in Canada, which then reduced acreage. And all of this together led the wheat prices double between June and September 2010. So what I wanted to know, what my team wanted to know was can we quantify the likelihoods of multiple breadbasket failure, and how high are those likelihoods that this happens simultaneously in different parts of the world? So for this work, I defined global breadbaskets for different crops, here maize, soybean, and wheat. and I decided to use state province level as my unit because I wanted to use observed historical data to do statistical analysis. And so you can see here my breadbaskets are in the US, in Brazil for maize and soybean, in Argentina. India is of course a big breadbasket, in China, and for wheat I also chose Australia. And the climate data that I used was Princeton reanalysis data. So to be able to quantify simultaneous climate risk in the global breadbasket, first of all I had to find out what are the relevant climate indicators. For this I did a huge literature review because the dependence or the correlation between crop and climate, as probably a lot of you know, depends a lot on the region and the crop. So I went through all the literature and picked out the relevant climate indicators, which could be like, for example, cumulative precipitation over the growing season, but also an indicator based on plant phenology, for example, the number of days above 34 degrees, which kills or which is really bad for wheat. I did then with my own reanalysis data, I did a correlation analysis with the observed subnational detrended yields and the reanalysis climate indicators. And if the literature and my own correlation analysis agreed, I picked one climate indicator. So this could be either one or two precipitation or temperature related indicators. And then the next big question is, what are actually climate risks and how do we define this? And for this I needed to find a climate indicator threshold, and I picked the 25 percentile here for maize yield in Santa Fe in Argentina, and I said from my detrended yield the climate indicator with a very simple linear regression that corresponds to the 25th percentile. And this will be my climate threshold. So here it's around 31.5 degrees, maximum temperature between December and February in Santa Fe, Argentina. And if my threshold is exceeded in my analysis, it would count as climate risk and a year under climate risk. And with the help of having defined a climate indicator and a threshold, I could start my analysis. And I started first in the past, and I looked, are there already increases or decreases in climate risk in the different breadbaskets? So I have here for wheat, maize, and soybean, either the precipitation and or a temperature-based indicator, and if it goes up, it means that the risk has increased already, and if it goes down, it has decreased. And my two periods that I compared were 1967 to 1990 and 1991 to 2012. And the overall picture so far is that mostly for wheat, climate risks have increased. And what was a little bit of a surprise to me was actually that for maize and soybean in Latin America, in Argentina and Brazil so far, the conditions were quite favorable. And yeah, in other parts like India, the risks have really increased. But then actually the work I'm presenting today is more about the future and the difference between 1.5 and 2 degrees. And for this, having done the analysis in the past, I used half-degree additional warming prognosis and projected impact called HAPPY data. I'm sure a lot of you are familiar with the data set. Why I used this is that you can compare statistics of extreme weather events simulated under 1.5 versus 2 degree global warming. And so, I mean, I don't have to tell you, you're the climate modelers. Usually you have like projections of the mean into the future. And the very useful thing for me about the HAPPY data set was that you see really a distribution of possible future climate conditions. So it produces large simulation ensembles, which I need for my probabilistic analysis to look at the extremes as well. There are different climate models used in this HAPPY project, and for this work here, I used a HUD AM3P atmosphere-only climate model, and I only could use maximum temperature and precipitation data for this future work. So let's take a look at the results. Compared to the past, really in Argentina and Brazil, the risks are also increasing. And maybe another thing that you can say is that for temperature, of course, the risks are increasing, and precipitation is actually mixed. And in this analysis with the data I used, the precipitation risk for different crops in India and China are actually decreasing, and this is due to the fact that the HAT-AM3P model projects an increase in monsoon rainfall, and this is why here in this analysis the precipitation risk are projected to decrease. And the other thing that you can see is that there is a clear difference between a 1.5 and a 2 degree global warming scenario, and then a 2 degree, the results are more extreme. This is maybe interesting, but a work like this has been done before. So the new work that I added here is really the likelihood that in different parts simultaneously climate risks are happening. And for this, I need a methodology, and you have heard about copulas a lot in the recent days, so I will go very quickly through this method. The interesting thing about copulas and why they are so useful and so popular at the moment is that you can split the marginal distributions from the correlation from the dependence structure. It goes back to Sklar's theorem in 1951, who said that the marginal distributions, if the marginal distributions and the copula structure is uniquely defined, then the entire copula and joint likelihood is clearly defined. And usually you model that in 2 steps. You model first the univariate marginal distribution parameters and estimate them, and then in a second step you look specifically at the dependence structure. And to give you a quick, very simple example of how this looks, I used here the detrended wheat for Uttar Pradesh and Haryana in India. You see they're both normally distributed. And then really the special thing about copulas is that you don't have to assume a linear correlation. So here it turned out that the Gumbel copula was the most useful copula for this case, which means that for higher values they have a stronger correlation, and for lower values they have a not so strong correlation. And then taking this, I just, as a little example, I calculated what is the likelihood that actually in both of those states we have in the same year simultaneously a yield shock, so yields lower than 1 standard deviation below the mean. And it turns out that the likelihood here was 7.5%. And if I would assume independence between the 2 states, my likelihood would have been only 2.4. So this is also really important, as it has mentioned before, for the insurance sector. If we look at crop insurance, we really have to include those well-modeled dependence structures, otherwise we would underestimate the risk of crop failure. I have shown you the Gumbel copula, but of course there are many different copula families which can model specifically, depending on your data and on your case, different types of correlations. So another very popular copula is, for example, the Clayton Copula here on the bottom left. People who model drought often use the Clayton Copula because they have a stronger correlation for low values, like a low SPI, for example, and not such a strong correlation for high values, because it has been shown in some cases that if there's a really large-scale drought with a very low SPI or SPI, the correlation is much stronger than for normal conditions. What has been shown also a lot in the recent days was the bivariate copula. So you have 2 variables and how do they interact. But in my case, I had much more. I had up to 5 breadbaskets, or I did also the analysis for interbreadbasket between the states and provinces. And for that, I need really a multivariate copula. And I used something called RVine, which is a statistical tool developed to model multivariate copulas for up to whatever, I have here 6, 8 different variables. And it uses a tree structure to look at the different dependence between multiple variables, for example, climate indicators or yield shocks. Coming to the results, my results showed that there is a clear difference between 1.5 and 2 degree mean global warming, and that the risks of multiple breadbasket failure. So what you can see here on the bottom between 0 and 5 is the likelihood that this number of breadbasket experiences simultaneous climate risk. And the black one is the historic period, the middle one is 1.5, and the right one, the 2 degree world. And you can see really that the risks increase disproportionately, especially for maize. There is really a clear increase of risk of multiple breadbasket failure on a global scale. And in my last slide, because this is a session about systemic risk actually, I would like to quickly talk about the work that we're doing now, the next steps, because what we realized and what my work was often kind of criticized by the broader community is like, hey, you model the likelihood of shocks and production losses, but actually what is relevant for the society are the cascading effects and the trickle-on effects on the broader food system and not just the production shocks. So what we want to do at YASA now is really looking at systemic risk, which means like you start with a drought. A drought can have impacts then on the prices through trade bans, for example, the one in Russia. This can further increase the crop prices then, which can lead to food shortages, social unrest, which we have heard yesterday, and migration. So I think the next steps, what we want to do is go away from purely focusing on production shocks and looking at the entire system. And with that, I'm done. Thank you.
Thank you. Any questions? Let's start here, please.
Okay.
Hi, thank you for this talk. How reliable is your projections of your drought risk? Because most of the CMF 5 models is not reliable over India. So you are showing in future your crop yield will increase with the 1.5 and 2 degree warming. Second, you showed some result in Uttar Pradesh and Haryana, where most of the irrigation is done by using the groundwater. So did you consider that groundwater depletion in your model?
Yeah, thank you for your question. This is what people often ask also if I include irrigation. And this analysis is really purely looking at climate risk using climate models. And I think your question is totally, is really important. And in future work, I could also use, for example, crop models, which then look specifically at groundwater use, irrigation, and this is purely an analysis of climate risks without considering those other aspects. But you're right, this is very important to include as well.
Any other question? Yes.
So mine's more of a comment. I think the audience probably doesn't know what the happy experiments are. We host that at Berkeley Lab in my group. It's a set of AMIP-style experiments of an idealized, stabilized 1.5 and 2 degree future. So to answer the previous question, at least the SSTs are prescribed, so we don't have that error. What my question to you is, there actually are 6 other happy models. Have you looked at any of those? The response in extreme temperatures is actually quite different between them.
Yeah. No, so to be very frank, this was still part of my PhD, and when I did this analysis, the HAPPIES project was just really starting, and HAD-AM3P was one of the first models that brought results, and I started my analysis with this. And you're totally right. Usually, the better way to do this would be using several models and then calculate a model mean, or just compare and look at the uncertainty between different models. And for this specific work, I didn't do it just because of time constraints. But you're right, in the future, if I would do this again, I would compare different models as well.
Thank you. Just maybe one last question. Are you going to get rice into the analysis?
So actually, some of the graphs, they did have rice included as well, and I cut it out because the future work about 1.5 and 2 degree included only 3 crops. But my work in the past also includes rice. But there the thing was, because irrigation is so important, and I don't include irrigation in my analysis here, it was really difficult, and I had to include solar radiation as a climate indicator as well, not just precipitation and temperature.
All right, thank you, Francisca. We have David online. David, I don't know, can you hear me?
Hello, yes.
All right, we can hear you. So I think we're good on the audio side. Is there a presentation to?
You hear me well. Thanks. First, thanks again for the invitation. Highly appreciated. Also for your understanding, I couldn't join in person. So I really look forward to share whatever 10, 12 minutes of some of the things I thought might be worth putting together. Then looking forward to a bit of a conversation or a Q&A. So what I would like to look into a bit is the question how we will connect all these loose ends, say, from the one extreme, understanding a climate system, to the other side, to operate a system, to take decisions in the real world. You probably know I've been 16 years with Swiss Re in many functions, looking into how you make best use of latest science in order to take informed decisions in risk-taking. And that's why on the bottom of the screen you have that a bit. It's really discussion how we make sure this translation really happens. And it is a translation, so it's not possible that decision makers learn all the scientific language, and likewise it is impossible for say us now as scientists to deep and fully understand all the ramifications that happen in business. And just before I delve into the topic, I mean, climate change is a long-term issue. Strategy of the horizon, as recently stated by the chairman of the Bank of England, Carney. And so for business, it's not so easy to put that all together and to disentangle this compounding in order to be best informed. And so what I'd like to share is a bit of what I think could bridge that gap, and definitely highlight one or two areas where I think we should also spend some time on, say, not only on the hazard side of things. And I guess the colleague from Swiss Re, in fact, I think we haven't met in person at the time I was still with the company, probably Jane Leuter, might have shared this one, such that basically last year, secondary perils and secondary effects have been kind of almost the dominant part of natural catastrophe losses in 2018. Now, it is a bit to the definition of Swiss Re, that's why I put it down. So they see primary perils mainly as tropical cyclones, basically just tropical cyclones, earthquakes, and winter storms as the drivers of their portfolio losses. And then things associated like induced precipitation, storm surge is seen as a secondary effect. So we could put that a bit into the compounding story as we've heard during the course of these days, and that's also mentioned in other sources. And then you have the secondary perils. In some places, river floods and wildfires are the dominant perils. So it's a bit of one way to put things in baskets, but you see from there, only focuses on tropical storms might not do the trick. And so that's why I highly appreciate we as a community look into that. And why we look into that, possibly one way I would suggest is the paper we recently put together, where we said, look, it is risk in the center, but it's not only driven by changes in hazard, the climatic drivers, it's at least as much driven by non-climatic drivers, socioeconomic development pathways, and the actions we take, because we can take basically actions which reduce risk in one place, but they might not work on a portfolio, or the other way around. Things might work very well on a portfolio level, but we still might struggle in a local sense. So bringing these risks back into impacts in all these dimensions is definitely one area we should work on. And we all know this all happens in a large climatic context, and by no means, and let's just say it once here, this is by no means an excuse to mitigate. It's just how we manage these risks since we're deep into, may I say, trouble. So now if you look at how we do such a kind of risk thing, and I don't want to go into detail, basically you run this as a probabilistic impact model. So you have the weather or the single events, weather events constituting the hazard. You combine it with exposure and vulnerability. I, in fact, often rather would suggest to call that an impact function, because vulnerability has very many, especially sociological connotations we might not so much be able to fully render in these models. And you get out as an output a risk analysis, a mapping, and you can use these tools, for example, also for early warning, as you see a bit on the right side, where this single hurricane hits US, and you can trace it. That's a 1 kilometer resolution to quite fine grade. That's only the first step, and that's only, say, one of these driving hazards, and then you have to disentangle what the consequences might be, very much driven by socioeconomic questions such as what does exposure change over future, and that's why you can use these models not only today, you can use them in a forward-looking sense. We know that obviously can force them with climate scenarios, so we can use other hazard, kind of future hazard, but you can also put in development pathways and, for example, development scenarios, and then run them as if we were in 2040, if we would at all know what the world looks like by 2040. It's in fact easier to chart out the pathway, what the world looks like in terms of climatic system than what it might look like in terms of the socio-economic system we're dealing with. And then last but not least, you can put in that system, and I just named it here, adaptation actions, and that was the same name as we had on the previous slide when we looked at compounding fashion of things, and you can basically appraise these adaptation actions or options, look at their effectiveness. You can look at their cost benefit in a close and a narrow or a broader sense. You might also do something like a multi-criteria analysis where you run the same hazard hitting a population, so people at risk, hitting infrastructure, hitting businesses, and you can then basically, that's what I would say is the downstream element of the compounding story, to say how do these things then combine and how you take a decision in such a multi-dimensional kind of a space. And what you can also do with these models, obviously, is to quantify uncertainty along the whole range of impact, the whole chain of impacts. And that's what I would like to spend a minute or so on. But before that, I just wanted to highlight that such a piece of analysis is only the core of a much wider endeavor if you want to really understand what's happening. So we term that often economics of adaptation, and I just highlight in this presentation here, we only look at the risk analysis, say that the modeling, the putting the things together part. We do leave out the stakeholder engagement, the wider discussions that especially need to happen once you have kind of preliminary results. You have to play back to the audience. They might not really share your view, and that's an extremely interesting and extremely important discussion to have, and to see that a bit from the shady thing in the background. You have to go back to the drawing board and even revise your model, because it could be the decision criteria might have changed over time. And that's just part of that conversation you have, this translation effort between understanding the climate system and how we deal with it in decision making. We've applied such a kind of a thing in many places. I felt for the brevity of this talk, I just bring one slide and it has a link to it, so you could look up all these case studies where we basically look at a wide range of hazards, different economic sectors, and especially risk cultures. I cannot say more about that here, but it's a fascinating topic that different cultures, different circumstances lead people to work or kind of to cope and manage risks quite differently. And what you find in all of these studies, and that would be the disentangling piece, is a kind of this picture. So most places, risk today is the dominant piece of the equation up to 2030, 2040. So the next decades, if you do understand what happens to you today, you're in a pretty good position already. And then development is often the key driver of risk, and climate change, even under kind of an RCP 8.5 type of a world, by close to mid-century is often not the dominant ingredient. As we do develop, as we create and increase our exposure, especially coastal areas, and also as our changing of the impact side, so our vulnerability is often not commensurate with the development of risk. So some of the structures we currently build, they're not climate compatible, neither on the mitigation side yet, and sure not fully adapted to a changing environment. But there is hope, and that's the green arrow. We can cost effectively reduce risk, and that's what I would like to show in one or two slides, and then a few remarks on uncertainty, and that's probably all I can convey today. And I should have said that's all underpinned by an open source model, so it's also an invitation for you to play with that. We would definitely looking forward to that. So if we talk about uncertainty, it's this kind of well-known paper from Wilby and Dessay, where they looked at this whole chain of impact. It's a bit of a pyramid. It gets kind of scarily complex in the sense that each next step in that interference leads to further dimensions even of uncertainty. I don't want to highlight all of them, but basically even on the local impact side, there is still a lot that can happen and change, driven by different regional, global scenarios. And these scenarios are driven by emission scenarios. So this climate model is driven by emission scenarios. And then you have a plethora of adaptation options, and you might say, ooh, how the hell could I figure which one is the best? And I think it's a bit of a point here to make, rather to seek robust adaptation options or baskets of options than the optimal one. As under all these drivers of uncertainty, it's hard to see whether one would really pop out with this being the single one, the best one. And often it also means it's not a single option, it's often a group of things you should consider. And the world really looks mostly like that. So we normally don't have this full funnel of widening funnel of uncertainty full charted out. We have For some emission scenarios, some models. For some global models, some regional models. For some regional models, then coupled with impact models. And for some local impacts, we do have local studies and a deep understanding. So it's also the risk, would we optimize in such a world? You see that the kind of the extremes of the distribution might not be charted out. And an optimal algorithm would, for example, to jump one of these three at the bottom, and these adaptation responses, and they might all be robust, but it could be they do not withstand further forcing. So it's really worth playing that all through, and that's a bit probably I would say a call for the interoperability of models, such that we build models who can cope with that type of a challenge. So what I'm just going to show very briefly is you can run the same model as shown before, but now wiggle everything. So you wiggle different scenarios, different development scenarios, different adaptation options, and you get kind of a bit of a blurred picture in the adaptation cost curve. And let's just take the case for Barbados, a study we've done in 2010 and 11. So you see risk today, saying you end up with 60% risk 2030, and that was done in 2010, kind of nominal numbers, so in 20 years from now. And then you can look at a basket of adaptation options, but I'm not going to show what they are, so I refer there to the link is on the bottom. But basically, some are attractive, the greenish ones, and the not so attractive ones are red. It means a lot of effort to achieve something. And the horizontal axis here is the averted damage. Now, if you play that moderate climate change, you see there are a couple things in dark green which make a lot of sense. There are things which somehow make sense cost-benefit-wise, around 1. And there are some which are reddish, which are not so attractive. And now you can start playing that uncertainty. You can go instead of moderate to high climate change. And you see the thing is changing a bit. Obviously, a bit more damage is averted because these options are more often used, in a sense, as the stress on the system is increased. You can then also say, what happens if I take another data set? That's probably mimicking a bit a different, say, impact model or even regional model. And you see there's quite a change in the distribution of exactly the things if you change the database, but still the order stays the same and a lot of things still make a lot of sense. Then you can go further and be bullish on the discount rate, say, no, I don't value the future as highly as today. For example, a 5% rate, I wouldn't do so, but just to play with. And you see still a lot of the curve remains in the dark green and is kind of attractive to implement. And you basically can play that all. And what you end up with is this type of a picture where you could say the greenish shaped area are all these things you could robustly do on the different kinds of assumptions. And basically, when you look into those, you learn especially the most effective ones for Barbados are ecosystem-based, so green infrastructure, and then a lot of is planning norms, building norms, so not easy to implement, but these things would do the trick in the region. So what I wanted to show here, if you play these models and play them for all possible future outcomes, you can learn a lot about robust adaptation. And now we could use these models also in the compounding sense, instead of running them with one hazard, because mainly here tropical cyclones, to run different hazards and start plotting that on top of it. It gets a bit noisy, but it would help us definitely to find the space, the robust adaptation space, so to say. What we could do, and that's just a very short animation, playing that now not anymore on seeing an island, but on a globe, so we could simulate large regions and look at the compounding effects of, for example, hurricanes on a regional economy, and then play that through even through things like trade flows. We started to work on that, but I cannot show results yet. So that's more a bit the kind of view in the future where I think we should go, namely because if you think about adaptation, it's not so much the story on the left, where you have the ND gains or vulnerability type of based index, where, for example, Central Europe is not at risk. And if you turn that into a trade flow picture, as done by the Transnational Climate Impacts Index by the Stockholm Resilience Institute, you start to see that quite some part of Central Europe becomes reddish because we depend so much on trade and trade flows. And we should kind of start to map that into the picture, as otherwise local and national adaptation might be a bit misguided, if I might say so. So brings me to my conclusions. I think I want just to remind us all again, risk is all about whether you want to achieve something. So it's the effect of uncertainty on objectives. So we need to know where we want to go. Otherwise, it's very hard to talk about risk. Second, the socioeconomic drivers we've seen, they do really dominate for the next decade. So that need to be taken very seriously into account. And I think it's really that the impacts matters and the actor's perspective, since I couldn't spend too much time on that. And I would say, despite a high level of uncertainty, mainly atmospheric uncertainty, we can find baskets of robot adaptation actions. But I think to really advance our understanding, not only, but also improve the usefulness of our knowledge, we do need to make sure our models become more interoperable, because I think it takes us still too much and too long a time to connect these things. If you think, for example, connecting, say, the community that looks into tropical cyclones with the flood community and talk about impacts and combining those into impacts in the direction of trade flows, there's still a lot of work to be done. There's still a long way to go. But I think, and that's the spirit of these two just remarks I put on the bottom, I think for the end users, this is some kind of an expectation, because what I've seen often, if we presented these single hazard type of results, people always ask, what next? What about wildfires? And if you did the story for wildfires, I said, what about torrential rain or kind of surface runoff? So you get this never-ending story, how you put all these things into perspective. So I would like to end here and say, I think, number one, there are other drivers, obviously, than climate we should very carefully consider when we think about bringing these things into the decision-making realm. And second, as I mentioned, I think we have to make sure our models talk to each other, as we do already. And with that, thanks for your attention.
Thank you, David. We have time for one question. I do see one over there.
Do you have any insight about the limits of insurability from your work?
I didn't fully grasp it. So you said, could I say something about limits of insurability?
Yes.
Yeah. I didn't show that, and I'm still a bit wary of my background. So I could have shown the kind of the risk transfer implications of these things in some of the places we've done that, and looked at what's the contribution of robust adaptation in basically maintaining insurability. And the short answer is it's tremendous. So if people do not invest in preparedness, and even in kind of early action, or kind of be in the planning side of things, it becomes in some places quite hard to insure from the first dollar on, as especially if things increase in frequency. You have a bit of an issue with too often being able to cash out, or having a need to cash out, and that does not do the best to the economics of insurance. But if you go for the extremes, and you, for example, say, like on a reinsurance or natural catastrophe kind of exceedance type of covers, there I'm less concerned, in a sense that if well managed, it can be insured. Insurability is basically all about, number one, risks must be quantifiable, otherwise it's very hard to put a price tag on them. But since you do have this price tag, you can also use this price tag to incentivize risk reduction efforts, such as the ones I kind of shown in a glossing over type of a fashion. If you look at these adaptation cost curves and you read the horizontal axis, it's normally order 40 to 60% of the damage you can cost effectively avert. And that would basically mean by something like 2040, you're kind of on the same risk level as today, which remains to be, for example, insured if you take these actions. So it doesn't come for free, and it needs a lot of effort, but it can be done.
Thank you so much, David. We're going to move on now. Appreciate you joining us remotely. Next up, we have Bill Travis coming from the University of Colorado, and this is our last talk, right, leading into the coffee break.
What an honor it is to be the last speaker. And I've learned so much in these 2.5 days since Tuesday evening from all of you in this big, friendly city. Friendlier than you might know, coming to New York City for like the first time in 50 years. I also learned I've got to go and learn copulas. I'm gonna do that. as the reviewer number 3 of a recent paper suggested to me and my co-authors. You all know reviewer number 3, don't you? Oh, it got accepted yesterday. During the fire drill, I got the email. Our group digs into this role of, what do you want? Did I just lose you're not hearing me? Our group digs into what David was just talking about at the decision maker level. Our group in Earth Lab and the Western Water Assessment, which is one of the RESAs, like CC Run is here, has supported this work of the climate risk team. And that didn't advance. And I practiced this yesterday. And it's not working, huh? I did practice. I really did. And about 12 minutes and 15 seconds. Thank you very much. And we use adaptation modeling as decision modeling. We ask questions as you just heard. When is it time to adapt? What choices pay off under different circumstances? And what are the limits to incremental adaptation using decision analysis? We pay special attention, of course, to expected utility, but realistic options and care for risk aversion among the decision makers. And as has been mentioned, and Kate White mentioned this 2 days ago, adaptation pathways and when you need to change those. And when we heard about this workshop, we took an existing suite of models that we use, that we've managed to build over time, and ran some of them with the idea of correlated extremes, realizing that we might not have been doing enough of that. We do sensitivity analysis, but not always asking the question about different types of timing and correlation. So we were inspired by Colin and Bradley to do that. And I'll just mention, you often see this graphic from the group at Delft and Del Paris of adaptation pathways, drawn with the colors and the diagrams, I think, of the London Underground, right? And the idea is that you're on a pathway and you analyze through options analysis, when can you change, when should you change, can you come back if you change, what will be the net cost of switching at some time in the future? And we apply these in different ways, and I'll give an example. Here's a farmer in North Dakota who's facing climate change that's reducing crop yield, and over time, crop yield is declining, the standard deviation of the yields is actually increasing, making it hard to see the signal, so that the decision maker may be a bit confused. And then what we do in the model is throw in a drought to see when it changes the timing of that switch from the typical continuous cropping to a more conservative dryland cropping, and then throw in maybe even a bigger drought. By the way, this is the 1988 drought that's been mentioned a couple of times already in this workshop, to see how we can move forward or back the timing of adaptation in the model. So that's the type of thing that we do. I'm going to look at this. This is a model of ranchers making decisions. We developed it mostly because of a new insurance program that the USDA just put in place a few years ago, a weather index insurance. And we asked ranchers then to decide whether to use the insurance or not as they're making decisions about drought. It's anticipatory, it's maximum expected utility with realistic options. And so I asked my colleague, Virginia Iglesias, just spoke, to take our actual record of forage that we run into the model, which we get from the Agricultural Research Service, and add some serial autocorrelation for me. And so here's the actual record, and here's the serially autocorrelated record. And there's actual, we add some serial autocorrelation so that the droughts start to clump in time. Same number of droughts over the simulation. And darn, the first thing I would think is, okay, we put droughts together, this is going to be tough on the rancher. And in the runs, on average, and in individual runs like this one, it works out to be just the opposite. The ranch made more money in a more serially autocorrelated time series than it did in the one that was the actual one. So this is, of course, an effect of the model. We don't have to go back to the real world to know what's happening. We just diagnose the model. And as much as it's realistic, we might have an answer. The drought calculator has a lag in it. After a big drought, the next year, even if it's normal, according to the ARS, produces less forage. So when you bring those droughts together and they occur in clumps, that lag year overlapped. So 3 distributed droughts are 6 drought years, but 3 droughts together are just 4 drought years, and the ranch makes more money over time by bringing the same number of droughts together in time. Now, I can make this ranch fail, and normal stress analysis would do this in this model. We take 5 years, this is the actual record. 2012 was a major drought in our area. And take 2012 and just make it happen again. So that the first 2 years of the 5-year record are both extreme droughts. And in the end of that 5-year record, yes, indeed, we can make the ranch show up with less net worth, but this has never happened in the record. So this is a system whose adaptation would appear to be really well evolved for typical droughts, including if they become more autocorrelated. I'll just end with the culverts model. So we look at stormwater stormwater system. We have a simulation of culverts in Colorado that take stormwater from one side of a road to the other without damaging the road. And we ask adaptation pathways. We give the manager of the stormwater system a set of pathways for adjusting to climate change. In the nominal approach, hey, when the culvert gets damaged, you replace it with the same culvert. And in concurrent, if it's damaged, you replace it with an increased culvert because you think that future rain events may be more intense. You can even, if your county commission gives you a budget to use, start to increase the whole system. Maybe you'll take 1 out of 100 culverts and just upgrade them with the money of a climate adaptation fund. In anticipation, or you can try to let climate tell you what to do. So I'll wait till the weather damages my culverts, and each one that gets damaged must have been sensitive to what's happening in the climate, and then I'll replace that one with a larger culvert. It works out that the nominal strategy, just replace them when it's time to replace them. It works for no climate change, but as the climate change factor increases, it becomes the least efficient approach. The concurrent strategy does better for you, and at high rates of climate change, you'd rather be in what we call the vertically flexible strategy, in which the model then looks for the best solution given this recent history of damaging events in this network of culverts. So just, we ran into there, how's my time? I got 4 minutes? I won't use them all. We ran back to all these runs, and this was just done like 3 nights ago, excuse me. Ran back to, Adam McCurdy ran back to all the runs, and he found all of them, there were about 300 in which damaging events occurred within 10 years of each other. And that's just because they ran them. This is without climate change, right? And then we took this set, here's 10 of them, and got the numbers from them. How did that change among those strategies? I'm only going to show one. We didn't do the climate change scenario yet. So here is the nominal strategy under no climate change. Keep going. And this is the one from those 300 extracted runs that had 2 damaging events within a decade. It wasn't that many, by the way. It takes a while. It takes a while for these events to occur because these are 100 to 500 year rainfall and runoff events. So there's not that many of them in the record. 2 things happened. Of course, the cost moved up of the nominal strategy, and the nominal strategy started to get a tilt as if it was experiencing climate change. We don't change the probability of these damaging events. We just extracted those that happen to occur near each other in time, inspired by this conference. Thank you, and say that both our 2 of our groups, Earth Lab and North Central, Jennifer Balch, sitting back there, directs both of those, and is, I think, as we speak, writing postdoc advertisements. So keep an eye out on this space. Thank you.
Stand up for just a second.
There's Jennifer. Watch that space. Thank you.
Any questions? In the back there.
Yeah, I love that you talked about culverts because culverts are such a huge problem and something that are easily fixed. So I'm really interested in that strategy. Could you explain again the difference between the concurrent and the reactive strategies?
Yes, the concurrent strategy. Oh, excuse me, and I might have said it wrong. If it was right on the slide. In the concurrent strategy, you don't upgrade.
Okay.
You just replace.
You just replace.
Yeah,
Okay.
and you replace concurrent with the event. And both of those, and I did have put citations on there.
Yep.
That work's actually been published both in Environment Systems and Decisions and in Climate Risk Management. Be
Okay,
happy to.
that's great. I'll catch up with you afterwards. Thank you.
And the culverts are so interesting because they kind of tell the manager, the county engineer. In our own county, 2013, we lost thousands of them. This is Boulder, Colorado. Vermont lost tens of thousands of culverts during Irene, I think. And we use both of those as cases to think about, well, which ones get washed out and what might you have done differently, on what pathways might you have switched to?
So I just want to make a comment that USAID is very interested in this for their work overseas, this idea of when to replace culverts. So I'll make a connection with you.
All right, I think, thank you, Bill. So thank you to all the speakers. I'm going to pass over to Colin now, maybe, to lead us into the break.
Yeah, well, I guess we'll just go to break. I don't really have anything else to say except for whatever Bradley has to say. But yeah, we'll think of speakers one more time and maybe just all the speakers.
So what we're going to do now is everybody go out, take about a 10-minute coffee break. Then we're going to gather for a photo right outside. And then we're going to come back here at like 11 o'clock real time. This is 2-3 minutes fast. And then we're going to have the report backs, just 2 to 3 minutes from each group, broader discussion. And then sort of closing thoughts, how we move forward. We do have some threads already of upcoming conferences, work groups that people want to tell us about. So be thinking also about that sort of specific, tangible next steps that we can all talk about. So we'll take now, we have one other request. If the steering group members, specifically anyone who led one of the 8 breakout groups, could come up so we can confer a little bit about the plan for the breakouts, reporting the breakouts. Thanks. Okay, I think we'll get started, everybody. Our final session, we're somehow gonna have everybody out of here in 65 minutes or so. So here's a sort of quick reminder of where we are right now. We're about to hear summaries of the report backs, essentially, in 2 to 3 minutes or so from each of the 8 groups. I think what we'll do is hear the report back by the single person from that group first for 2 minutes or so. Then we'll do a sort of wide open to anybody else in the audience. Was there something you thought was important from your group breakout that you'd like to add to this? In the context of the questions that were discussed. And then from there, we can go to an even broader kind of discussion. What else do we need to be talking about here that maybe may or may not correspond to the kind of questions that we had put up there? So really a broad discussion. I'd especially want to emphasize voices that we've heard less from, maybe over the course of the workshop. Please speak up. This is, we really want, realizing, for example, hardly even referred to the incredible poster presentations we've had the last 2 days. These are additional times. Let's hear all these voices, these broader perspectives in the room. That's what this is all about. Then we will have a quick awards ceremony, which will be a lot of fun. And then I think there's still what we'll make sure to do at about 12:15 is have a very specific conversation to make sure a few particular work streams that have been identified as ways for us to collaborate in the future aren't just mentioned, but are actually sort of like described for a minute or two, maybe with a slide. So that should have, sort of trigger further discussion of where we can go from here. And then I expect us to have more discussion about that topic too. Okay, so with that, I think I will turn to Amir to lead us off first, please, with a recap in 2 to 3 minutes or so of the findings from his group. And we'll hold additional commentary from that group until after all 8, but then we do want to have that commentary. Display for you.
Okay. All right, so just a quick summary of group number 1. We started with research gaps. So one thing that was mentioned, the focus of most of the presentations were on climate drivers. The group thought we need to do more work on non-climatic drivers, including human decisions, like, for example, irrigation or land use, land cover change, or human decisions that can make a situation a lot worse, or the impact of an extreme event worse than usual. So that's considered as a research gap. The other point was we learned about different types of hazards and extremes, but still disciplinary research within our own field. And we heard a little bit about health and some other topics, but still it is considered disciplinary research. Perhaps we need to go beyond and talk to other communities, maybe even social scientists, and get into that aspect. Socio-economic dimension of compound hazards, again, was another type of gap, at least in this community. Maybe beyond this community, there are people working on it. But things like coping capacity, the same event in different parts of the world will have significantly different impacts. Those are things that, we need to work on. The other one, most of the studies had this long climate scale type perspective and focus. And the idea was we need to also focus on S2S, subseasonal to seasonal forecasting, because that is probably more relevant to decision makers. Then there are other topics like coastal erosion, sediment, water quality, and lots of other things that were not mentioned, at least in this group, but probably there are other communities working on similar things. In terms of gaps, again, defining extremes based on user needs, considering one or multiple types of hazards, but different stakeholders, their thresholds, their ideas about extremes will be very different. So perhaps focusing more on bottom-up research that starts from stakeholders and user needs, then developing science around that. And finally, maybe linking some of our basic definitions like return period and things like that that we use all the time for describing hazards to impacts, like really trying to connect the indicators we use for describing hazards to actual impacts of compound events. In terms of data gaps, the main thing was data on impacts, and not just impacts of major extreme events. Those usually we have some idea about, but moderate events that don't end up into like news and whatnot, but still they are important if you want to look at drivers of events. Data about human dimension and lots of other things like groundwater, soil moisture, and so forth. So I'm trying to keep it short. So then we talked about how to make the science more like decision relevant. One of the points was that we have to start from, again, the decision makers and going bottom up, first identifying what type of decision are made, but what type of stakeholders before framing our research questions and hypotheses. Another point that was mentioned, there are already funding opportunities and frameworks for linking basic research to application and stakeholder needs, like NASA Applied Sciences Program and NSF has interdisciplinary programs. So the frameworks are there. You just have to try to fit this type of research into those existing frameworks. Also, the need to connect to communities that develop building codes, design codes, and those sort of things, and understand their needs and provide like climate information relevant to those sort of applications. Then we talked about question number 4, which is how can these themes be mobilized to engage more stakeholders. One point was quantifying impacts beyond just dollar values. Like, for example, impacts on forest, ecosystem, I don't know, flowers and things like that, that it's hard to assign a dollar value, but they are still really, really important. Reaching out to existing systems we have in place for like drought monitor and other systems for communicating hazard, and making sure that they are aware of what's going on in this community and interact with them to make sure that these ideas of compound hazard will end up in the existing systems we have for predicting or monitoring droughts and heat waves and so forth. And finally, connecting to emergency managers and institutions, including even Red Cross, local and international, to better understand their needs. This was just a summary. There are other points that maybe we can talk more later.
Thank you. All right, Olivia, let's go to you next.
Thank you. So in group number 3, it was recognized that the approach is taken at this conference to bring together engineers and climate modelers, climate people is really important, and we need to go further along this path and try to establish this bridge even more firmly, and that we need to focus specifically on the questions of vulnerability and resilience. And I'll come back to that point again. Then we discussed that the exchange of impact data and access to impact data is still challenging. That can be due to privacy restrictions or format issues, and we should invest some efforts to make the data exchange easier. Also, data exchange with social scientists who have a lot of qualitative data. Then we had some discussions that the current academic incentive structures often do not reward stakeholder engagement or studies with a local focus or interdisciplinary work, and we should try to change that. And then as input for a next workshop or for steps forward is there were several people asking for a more comprehensive overview of statistical methods beyond copulas that could be used to study compound events. And then it was mentioned several times that we should reach out to social scientists to learn about their qualitative methods that they use to engage with stakeholders, and also to learn more about social vulnerability and resilience, because these are key ingredients when it comes to impact. That's it.
So I don't have any slides, sorry. So we've talked a lot about 2 topics, I would say. One of them was the issue of data, and it was people emphasizing a lot that if they want to look at impacts, that sometimes there are huge barriers to look at, for instance, health data, that the people that actually are doing the health work, sometimes they want to keep the data for their own analysis and from their own work. And so we are trying to discuss how would be possible to engage more so that we have access to this data. The other issue that was pointed a lot is actually on the other side, that people trying to use climate data in a wrong way, in a naive way. Just get, for instance, one grid point in one model and assuming that is the projection that's going to happen in 2000 and the end of the century. And how can we, as climate scientists, help avoid people that are downscaling the data or just using the data in a naive way, help that not happen, because we know that's the wrong way of using the data. One thing that people point out that climate service could be a way to help that. For instance, in Australia, they say there's actually one person that's responsible for this relationship between the climate scientists and stakeholders, and they help translate these data issues. And also in land use universities here, you have also climatologists that usually they make this translation, but maybe they can help in terms of extremes, in terms of climate change, which is not clear that they're already doing that or not. So that was a lot of the focus of our discussion was on data. The other issue that people point out that some people are confused about the whole definitions of compound extremes, correlated extremes, sequential extremes, that, you know, each person would come here and say, that's my definition, that's my definition. So I know that in Jacob's paper, that's part of what people try to do, put a compound definition there, maybe in terms of, for instance, even IPCC, they were saying, how can we in IPCC use the definition of a compound extreme in a very specific way? So that's another question. Do we still need to discuss more about the definition of compound extremes? Because it seems that at least in this workshop, each one are using their own personal definition, which, you know. I think that were the two main points that we discussed, and I'll leave it there. Thank you.
So I just want to highlight 3 points from our discussion. Actually, some of them are quite close to what Amir already said. So one point that was discussed a bit in our group was that often you can have extreme impacts with non-extreme drivers, and you can actually use this. So with non-extreme correlated drivers, you can use this information also to communicate a risk better, because people are more familiar with, let's say, a 1 in a 5-year event, maybe a 1 in a 5-year storm surge, 1 in a 5-year precipitation event, but that can then come together to create a 1 in a 100-year or 10,000-year flood because of these interactions. And so you can actually use these correlations at a more moderate level of extremeness to make people aware of those risks. So you can use this also for storyline creation. The other point that we discussed about was a bit how to include the human dimension. Is related to Amir's point before. So how can we extend? So we have seen all these talks today and yesterday. How can we extend this more climate perspective into the human dimension? Include, for instance, dam operators and management, people who have management decisions, crop management decisions, reservoir management, fire ignition. So all these aspects can actually compound the compound climate events and lead to completely different risks depending on how you include them. And finally, we discussed a bit about to which type of communities we should reach out, maybe for funding or raising awareness. And there we discussed a bit about real estate people, so they really have a long time horizon, how to plan and how to deal with risks. Medical services were mentioned, finance investors, and then also, again, people who develop industry standards, so that we raise awareness there.
In our group, I took the prerogative in the beginning to steer the discussion towards users and stakeholders and such. Our group was mostly physical scientists, but a few had some social science experience or collaborations or stuff. I would say roughly my perception of this larger group as a whole. And so it ended up being sort of a sharing of stories. There was people had different projects and different things they knew about, and we talked about some agricultural things and dams and infrastructure and different situations where science and user and stakeholder needs and issues interfered and interacted in different ways. There wasn't any single resounding theme that came out. It was sort of a textured set of stories that I found pretty fascinating. And so that was one thing. There was a discussion. We got into politics a little bit and talked about how can scientists
influence policy, and I think we had agreement that that the information deficit model is not right. It's not a matter of us just communicating better, and then that'll make things happen. That there's real, real questions of political conflict and competing agendas that have to be addressed politically, both on the mitigation and adaptation side. And then one thing that I thought was worth bringing out that came up in the context of that discussion was someone brought up the Bloomberg task force on climate-related financial disclosure. You probably don't know what the thing is, but I have trouble remembering the name of it. I might have gotten it wrong. But it's this group that issued this directive that companies should disclose their climate risk, which has a component about both the risk if there's a price on carbon and how that affects the business, but more relevant here is the actual hazard impact risks to business. And so a lot of groups worldwide have been signing on to this, and so a lot of companies feel a need to quantify what their climate risk is, and I think most of us would probably agree that the tools and methodologies for doing that are still very, very primitive in most cases. And so that seems like a potential, one of the questions that Radley and Colin posed is, what are potential new funding streams? I don't see that there's an organized funding stream yet around this, but it seems that the need is so large, the amount of money involved is so large, that this is something that as a community we should be anticipating, how the work to quantify climate risks is going to be done, how the methodologies are going to be improved, and maybe we should be organized and think of how to try to direct that so that some of it goes to be used in constructive ways that involve academia and public sector, as well as private sector actors that are already engaged in it, who we of course want to work with as well. I think I'll leave it there.
So I'll quickly talk about what we discussed in Group 7. First of all, we had 8 climate scientists in our group, 2 people who identified themselves as more like coastal engineering / oceanography, and 1 human dimension of climate change. So again, probably reflecting what's happening in this bigger room here. One thing that's important in our group, we were mostly early career scientists, which kind of steered the discussion in a certain direction. I'm focusing on this question 5, and I will come back to that in a second. We didn't really stick to too much to these questions that were posed, but the first part, I think, was more about questions 1 and questions 3. One thing that was discussed was the scalability of people's research. We saw so many talks looking at different spatial scales, global to very local. How can we connect these scales, and how can we pull things together and integrate them? One thing that was discussed was the lack of the presence of social sciences. There was some, but I think it could have been more. And of course, there are different ways of trying to promote that in the future. One idea was to next time have social scientists involved from the beginning in the steering committee, have them help shaping the text that goes out on the website, and make that more attractive for people with a social sciences background, which maybe was not perfectly done this time, but I mean, that was the first time we did it. And it started with a group of climate scientists, so I guess that's one thing that we can improve if we repeat this. Also, terminology. People said that they know about work that has been done in the agricultural sector on compound events, but they don't call it compound events. So this buzzword that has made it through many of the disciplines that are represented by people in the room may not have made it to other disciplines. Question 2. The data stuff, again, social data I think is important to be connected with the physical science data, survey data. How do we do that? There's sometimes a lack of common data format, which already scares us away to not use the data if it's not in a format that we are used to handle. Also issues of getting data from developing countries. And then question 5, and again, that's because we were mostly early career scientists, we ended up talking a lot about funding opportunities, because many of us just started out or about to start out to jump into this grant writing business. And with people from different countries, we talk a little about what opportunities are there at the national level and what opportunities exist at the international level. I learned that there's a Belmont call. Right now, Belmont Forum has an open call on disaster reduction, natural hazards and disaster reduction or something like that, where compound events are actually covered. So US, UK, China, Japan, people can collaborate. Here in the States, we have the NSF PIRE, which is an opportunity for us here in the States to collaborate with people internationally. Also, only certain countries, not everybody can be involved. It depends on whether or not your country has a deal with NSF. In Europe, there are multiple funding opportunities, again, often only for European participants, but sometimes international partners can get involved. And one way to maybe improve that was also to make sure that program managers are aware of these meetings. And maybe they don't have the time to come to a 3-day workshop like that, but if we were to add a smaller workshop as a side meeting to EGU, AGU, program managers are there anyways. So maybe we can pull them out for 3 hours and have them sit with us discussing these issues. And maybe that helps getting this whole topic more onto the radar. And then from that on, we also talked about which conferences are interesting for us. And I sent a list with a whole bunch of acronyms to Colin and Radley, and I don't know all of them. One that I want to mention is the EVAN Conference, Extreme Value Analysis and Application to Natural Hazards, where the deadline for abstract submissions is on June 4th, so very soon. That conference takes place in September in Paris, and it has a session on multivariate extremes. So everybody working on natural hazards, doing any kind of extreme value analysis, univariate, multivariate, stationary, non-stationary, spatial, please submit an abstract. That's it. Thanks.
All right, so group 5, I think one of the things we wanted to talk about was we had a short discussion about how we were kind of all there because there are these missing risks that kind of a lot of us understood that the current situation is not really capturing all of the potential cascading and secondary effects. There was a little bit of we identified a little bit of a strange dichotomy between the fact that these are extreme events and by nature there aren't too many of them in the data record, especially when we're not sure if it's a stationary data record. But at the same time, there's this revolution in big data analysis and machine learning and things like that. So it kind of is calling out for some mix where we get into the virtual space and explore possibilities that are not directly observed so that we can use those powerful tools. And one thing that we talked a little bit about was the storyline approach, kind of focusing our attention on the most interesting narratives and creating data sets around those. We also, in terms of what it all means, we first of all, I want to recognize that these breakouts happened just before we got into all the social and kind of multidisciplinary things. So I think some of this has been addressed later in the week. But certainly one of the big topics was this idea of inverting the model. And instead of starting with what the climate data can do and kind of pushing towards the stakeholders, kind of invert that, ask the stakeholders, what are your goals? What are your challenges, and then kind of work back. And part of that also gets into the design of how we approach it, how we build data sets, and the decision support tools that we're after. One of the areas that we identified as missing was kind of the area of operations engineering and logistics models. This is really important as you have concurrent events and you see resources flowing in one direction, which means they're not somewhere else. I wanted to just close with the last exercise we did where we actually realized that between at least sequential and concurrent and compound events, those are all kind of under this umbrella of correlated extremes, and we've heard about them at this workshop, but they really are different approaches and different kind of needs as we're trying to plug this into a stakeholder perspective. So we came up with a couple phrases, and I'm going to say them here, but we have them written down, so we'll pass them on to the note takers. But for sequential extremes, we felt that what was really needed was kind of better understanding about how we can monitor current, let me say this again. How we can monitor current changes in the risk profile which affect the consequences for the next event. So it's basically if you're preconditioning because of something that's happened earlier in the season, how does that change what's coming later? I didn't say that very well, but I have it articulated better here. In terms of concurrent event, what's really needed is systems thinking that connects different regions of the globe or different aspects of a system. So in particular, the resources, the responses, and the influences across a connected system is needed to really understand those concurrent events. And that has to go across space and also decision context because operators in different parts of that have different influences. Finally, for compound events, There's a big need for multivariate approaches. We've heard this. We've heard about definitions and many other things here already discussed in the breakout reports. But also there's a big need for better understanding how specific sectoral assets respond to multivariate kind of multi-stresses. So there's, in that sense, a need for process-based models and other things that are actually able to see multiple hits and be able to draw those things out. So I think we'll leave there.
All right, and then I think I'm last here. So I guess in my group, one of the main themes that came out and connected a lot of our thinking was when you're trying to include humans, like most groups, we have mostly physical scientists, so we were kind of thinking about the difference between what we, I guess, typically do or have been trained to do and sort of including human behavior and fallacies a little more. And when you have human behavior, you have to really include, we were realizing, adaptation, incentives, and things like that, and those can change the baselines or the kind of expectations that we're implicitly folding into some of our especially longer term attempts at understanding systems. But we also talked about shorter timescales and how sort of when you have humans in the picture, including shorter timescales, whether that's sort of subseasonal or more like decadal prediction as opposed to centennial prediction, those can help sort of both in terms of understanding the climate system on human relevant timescales, as well as in communication and messaging. If you can, be able to say with more certainty that something will be more likely in the next 5 years, people are going to probably at least respond to that a little more than saying it'll happen in the next 50 years. And then I guess just shifting back to sort of immediate timescales, we actually had an emergency manager in our group, and he was saying about the response to the 2011 New Zealand earthquake, and that kind of segued into a discussion about how even governments who you might think are less incentivized or naturally money responsive than, say, businesses or other individual consumers, say, even in the case of governments, it's still largely about how much does something cost and what's the cost benefit analysis in terms of dollars, and so kind of trying to have a longer term or multivariate perspective as to costs and benefits of correlated extremes would probably result in different adaptation and response measures. So I guess that's all I'll say about that. Yeah, and I guess we'll move on to
discussion. Okay. Do we have mics still working? Okay, so now let's go. We want to start having discussion, perspective from folks. What did you not hear? Respond to anything you saw here?
Yeah, both of these mics work.
Hi, my name's Alex Sherman, and I'm at Season, which is one of the Earth Institute centers, and I've been sort of in and out, so I haven't seen or had an opportunity to talk with a lot of you, but I've been really fascinated by the presentations. Just responding quickly to some of the breakout group report outs, there were several that kind of emphasized the need to incorporate population or socioeconomic scenarios in addition to the biophysical or climatic scenarios that you guys are generating. We run something called the NASA CDAC, or Socioeconomic Data and Application Center, so we actually have future population projections at a 1 kilometer resolution, which are easily downloadable open access data. More broadly, I was at a meeting recently in March, which is called Scenarios Forum 2019 in Denver. Some of you, did anyone go to that by any chance in this group? Okay, there are a few. So that was a really interesting meeting of both the climate and sort of climate science and modeling communities and those who are involved in the socioeconomic development of scenarios. And so there is a group called Iconics. It's sort of under, but not quite, under the IPCC, developing the shared socioeconomic pathways and spatially explicit models of future kind of economic projections and demographics. So given the interest on the part of this group, I just thought I'd sort of announce that because it seemed like it was a recurring theme that there's a need to kind of incorporate some of those elements better. I will say that thus far, the number of scenarios and the types of things that are available are not as broad as might be hoped. So we basically have population counts, some economic projections. We'd really want to have things like poverty levels, sort of different scenarios on just underrepresented groups and things like that. And those are not currently available, but that community is working on it.
Okay, thank you, Alex. Another?
Hello, my name is Clayton. I used to work for the government of the city of Buenos Aires in the Clean Energy Department, working with the climate action plan of the city. Here in the United States, I'm working with climate advocacy. And I think it would be very useful if the works presented today could do some sort of contrafactual of a comparison of what's going on right now, what the relationships you're finding right now, and perhaps what could be happening without climate change or in the foreseeable climate change scenarios, 1.5 to 4 degrees Celsius. That would be very helpful to guide policies in the future if we are still able to, if we have incentive to mitigate, reduce greenhouse gas emissions, or if we're only looking for adoption and that's it.
So counterfactuals that extend into the impact space for the climate variables, but also into the impact space. Okay, we're here. I can stagger. Yeah, go ahead, Charlie.
Just wanted to support one of the statements in there. You're talking about the IPCC and talking about the financial disclosure. I'm with Con Edison, and we see on the financial side our investors talking a lot about sustainability, and that's become a portion of, is your business viable in the future under climate change as well? So they're looking at, can your business operate under what the future will be, or if the future is going to change, how will how will your product, I guess, adapt to that new environment that it's going to be working in or being marketed to? So there's a whole sustainability investment community out there that you should be paying attention to as a possible resource for funding of studies such as that.
Kind of dual meanings of sustainability. If I hear you right.
Yeah, because sustainability, this whole concept is it's environmental, governance, societal. So it's dealing with those three aspects. And so societal, it wants to know the societal impacts or how your business impacts society or is taking care of society, as well as how you govern your business. And if you have people that are paying attention to sustainability on your board. So they're looking deeply into how your business will look in the future. And part of it is coming up as climate change. They want to know how you're adapting to that.
Hi, my name's Tanya Havlicek, and I am from CoreLogic, so I'm one of the private sector folks here. I've had to be in and out a little bit as well because of some client obligations, but hey, what an awesome time here. I formerly wore a hat in academia, studied as an ecologist and system scientist. I'm an actuary, so I'm kind of on the pricing side a lot. CoreLogic, we're everything in the housing sector, residential, we also do commercial. What I wanted to share is I'm part of the leadership council with CoreLogic, and we've identified as one of our goals is to identify how to reach out more into academia and do more research and publications. So this is kind of a plug for me, kind of a plug for my company, but I house all of the residential housing in the United States with reconstruction costs. So I've got the exposure, and we do hazard reports. We do damage modeling estimation through our software, RQE. So this is just kind of a plug. Like, I love to do interdisciplinary research. There's a call for this within my company, and I would love to collaborate with folks. Just this past year or two, I've been dealing with these questions when we got our model estimates on damages with Florence. I said, well, did we consider how inundated the ground already is and the capacity to deal with the amount of flooding? How do we bring that into our models? I've built hazard affected loan performance models looking at post-Hurricane Harvey with that unprecedented rainfall, and then looking at the capacity of borrowers to make their mortgage payments in the wake of needing to do reconstruction costs after that. And so I just see a lot of opportunity. This has been so cool to be here. I guess my name's probably on the attendees list, but I'm Tanya Havlicek at CoreLogic, and I would love to connect with folks that are interested in looking at the impacts on structures and damages.
Thank you, Tanya. I'll follow up with a quick plug of our own to mention that Managed Retreat Conference coming up here at Columbia in 2 or 3 weeks. We're going to be taking on some of those same issues. It'd be great to have your perspective. Please.
Yes, hello. My name is Dr. Mildred Polner, and I'm president of Cinema Verite International, Inc. I've heard this has been an excellent program. I've heard people over and over again say that they have no social scientists, but you're wrong, because I'm a social scientist with a doctorate from Columbia University. And I am going to give you my website, how you can contact me, which is www.challengingfilm.com. That's all one word, and film is singular. I think this particular program, of all of you, could be the beginnings of a brilliant documentary on what may be in the future. And if any of you think you'd like to be a part of that, I would love to help you with it. Again, my website is www.challengingfilm.com. You could all send me your information at Cinema Verite International Inc. at gmail.com. I'm Dr. Pollner, and I think we're at the start of something truly brilliant.
Great. Thank you, Dr. Paul.
Can I have your card,
Great.
please?
Yes, later we'll do that. Thanks. Over here, any couple more? The others? Go ahead.
I think following the point on climate mitigation, and we talk about that risk and hazards and exposure is all important for adaptation, but I think it's also important to know what's the contribution of hazards versus contribution of exposure, so that can help as a guide into the mitigation policy as well. That's it. It's a comment I think we should stress. And yeah, it's good to have the total amount, but like knowing from which part is contributing more in terms of mitigation.
Hi, I'm Bob Smerbeck, a meteorologist at AccuWeather, and we have a lot of platforms to tell a lot of weather stories, and this would be a good time to start getting stories out about correlated extremes. You know, get it in the language and get people more used to hearing about it. So that's about all I got.
Maybe we'll have a way to share contact information if there's any more tangible. I think it's a great idea. If you want to think about more specific ways, open to suggestions. Communication theme, I think. Different communication needs for diverse audiences. What inspires, what frightens, what different approaches in different contexts, I think, are key. And I totally agree. That's an amazing platform. And, point that we heard over and over again is about leveraging existing sources of information, meeting people where they are. Others?
I just wanted to say something regarding getting access to health data, because that was something I dealt with in my project. And I found, so actually there was a pretty good daily mortality data set across the US that lots of studies cited. It used to be publicly available, and then sometime around 2014 it became not publicly available anymore. And I just mentioned that because I was able to get my hands on it through using some connections through the AMS Board of Environment and Health, which is a great resource if you're interested in working with health data. But I also mentioned this because I think it was unfortunate that it was no longer publicly available. So it's not just getting new data made publicly available, it's also ensuring that data sources that are publicly available can remain that way. And also just that there are some other data sets I tried to get my hands on, but I think there's an issue where these health data sets are very difficult to put together. And so my impression is once they're put together, the group that has put them together wants to kind of keep ownership of them for a while. So maybe if there's some way climate scientists can provide them with data in exchange, so it's not just, give me your data, that might help sell us to them.
That's where we're going to go. So we're going to maybe we'll circle back just because there's several people waiting. Go ahead, Alex.
Yeah, so I'm going to make a little bit of a provocative statement, but in many of the impacts communities, this idea of compound extremes and all these things is taken very seriously, but the idea that it has to be directly connected all the way back to the physical explanation is not necessary. So in many cases, it's just a scenario that they'll create. So for example, there are studies of multi-breadbasket failures where instead of modeling it, they just said it happens. And this feeds into what is, for lack of a better term, called war games, and people kind of try to play out all these things. So I think there's actually a big room for this community, maybe not to try to expect everything to go from end to end, but to say, can we change the probabilities? Can we change the type of storylines that are being passed into those narratives? I think would be maybe a more tangible target on the short term.
On the data end, we discussed in group 3 that sometimes we face this issue that different groups, different fields haven't got the same data format, and a common shared repository would sometimes facilitate the exchange of data. So that hasn't really come up, although it was touched on. Obviously, the climate people would advocate NetCDF, but then again, that isn't a universally accepted format, it seems. So if that's something that can be facilitated, would be cool. The other thing which I found interesting personally was that I sometimes had the feeling people push their research towards fitting into this correlated extremes theme, and the sequential events, that's, I think, something which would generally work better for the policymakers. They don't care so much about correlated or compound. So if you were to sell correlated extremes to policymakers, that was at least what I've thought. Many people said wouldn't work so well, so they don't care so much whether it's something's correlated or not. And in general, speaking of the social side of things, and that refers back to the very beginning, that was the panel discussion. How can we as a community influence policy or influence the social sciences? It would be interesting to actually look at the psychology side of things. That's what we discussed as well. So how come that within like 2 or 3 months in whole Europe, people talk about climate, and it's taking one 16-year-old girl to actually get this whole process started. So we can, do the whole deficit model approach, which was also mentioned, and it's going to fail. And there we have it. So that would certainly be a completely separate topic of for a conference or workshop, but something that's certainly interesting. And that's my thoughts. Thank you.
Yeah, so thanks to Radley and Colin and everyone for putting this together. I think it's been a really great and inspiring conference, workshop. Somebody mentioned in this discussion the need for kind of getting on the agenda of these funders, that, you know, we have these different communities in the US, in Europe, in Asia, other places, and in these different kinds of arenas, and it's very important that we link these. And somebody mentioned that we could push in kind of EGU, AGU kind of arenas where people from these agencies are there, this kind of message. Something with regards to that I would like to mention is that I was part of a group of people last year who put a proposal to the EGU Natural Hazards Division to actually put a new subdivision on multi-hazards, because we realize that there's a lot of the work in EGU, and probably at AGU happens either within hydrology or atmospherics or volcanoes or whatever. And that proposal went through, actually, so there is a new EGU subdivision on exactly multi-hazards, not just climate hazards, but all of those hazards, correlated, sequential, NATEC, whatever. So that might be a nice arena where we can continue some of these thoughts, I guess. And then a plug there, that Jakob and I do host a session at EGU, so we will later in the year be putting out a call for that, I guess. And it would be nice if many people here can also submit to that session. Thanks.
Shall I?
We'll just a quick response and then to you.
So I like this idea that you propose EGU, and actually I'm part of the AGU natural hazard section. So if anybody wants to do something on those lines, please communicate with me, and I can help facilitate that.
One component that I find missing in this event here is the whole aspect of urban planning, land use. It's represented academically as a group, but not here. But I mean, they exist. The land use practically has no body, because if I look, for instance, at the United States, it's home rule, meaning it's totally locally determined. We don't have regional planning or state plans of land use, where coastal communities develop and so on. So I wonder how this body can think about it, how to influence these important sectors that really determine where the impacts lie in the future. And they are a little bit hard to organize, but maybe future conferences can think about that, to bring both urban planners and whoever the land use people are, I don't know.
Right. So thinking about things like coastal planning for sure, but also things that we heard on the fire management side, including this ecological perspective and this sort of history of which types of changes are hard to recover. We're not taking second from anybody, and because of the demand. Anybody else like to speak? Good. Yeah.
Hi, my name is Laura Peters, and I'm a geographer and a social scientist. And I do my work looking at disasters and disaster risk reduction in places affected by conflict and social political crisis. And I would urge this community to really add in the complexity of the social and political systems in which you're seeing the impacts of climate change, you're seeing the impacts of hazards, because this is really what connects these types of issues to actual human impacts, and then strategies for mitigating those impacts.
Hi, I'm Rachel White from the Barcelona Supercomputing Center, and just building on that, I sort of have this sense of a lot of the compound events that we've seen have been an example of something that happened, and that sort of taught us about how these compound variables might come together, not as extremes in themselves, but they come together to create an extreme. And there's been a lot of that from the physical sense, but I think there's some sort of interesting ways of combining the physical system with sort of the social systems. And I think I don't have any answers, but it strikes me as interesting. How do we find out what are those compound events that we haven't seen examples of yet, that might either become more frequent because of climate change, become more frequent because of social changes, and that we can try and predict before we see an example and have to deal with the impacts, and start sort of trying to put some mitigation, change some systems before it happens.
Hi, I'm Yang Chen from China. Now I'm working as a IPCC TSU Science Officer for Working Group 1. So I would like to say it's really very, very important to clarifying the definition for different kinds of correlated extremes. Because like yesterday's discussion, we have concurrent, sequential, and compound extremes. It's important because it's not only matters for delivering exact information to policymakers, also matters for adaptation and mitigation policy developing. Because, for example, for sequential extremes, they may have first stage and then another stage. So the government need to prepare different kinds of events at the same month or the same year. But for compound extremes or correlated extremes, they may need different cooperation between different countries or different regions. So the matters for adaptation and mitigation policy, I think, is very important. And also this definition will be incorporated in the vocabulary for IPCC report.
Thank you.
Thank you.
Great. Yeah, this is Erin Towler from NCAR, and I agree, and I just want to dovetail on that. I agree that the definitions are important to kind of nail down, which is hard because I think one of the nice things about this conference is it's sort of exploratory, and so you sort of see that a lot of them do fit into multiple categories. But similarly, I think if we can come up with a definition with some understanding that there is some ambiguity, we can also, I think an important thing would be to identify the different tools that are appropriate for each of those. And within that, I think we can also identify some of the human dimensions that may need to be really important, like systems thinking or, so sort of just trying to map kind of systematically some of the different, again, some of the phenomena that might be linked, the definitions for them, and then the statistical tools that would be appropriate for each of the different categories. I think would be a good contribution from this group.
I'm Kath McInnes from CSIRO. I just wanted to add about the IPCC comment and just stress that on the upcoming special report on oceans and cryosphere, Chapter 6 is dealing with compound events and cascading risk and coming up with some definitions, bringing in the idea of sequential, coincident and so on hazards, and meshing that in with that classic thinking of risk being the intersection between hazards, exposure and vulnerability, and the flow-on effects through the sort of human systems. So that would be a very good starting point for thinking further about developing these ideas. And that's being released in September, or at least the summary for policymakers will be released in September in a couple of months' time. Thanks.
So Michael Wayner, Berkeley. I'm actually one of the lead authors on Chapter 11, extremes for the AR6, Working Group 1. And we have a section 11.8 in that chapter, Compound Events, which has subtitles of concurrent extremes at coastal regions, concurrent drought and heat waves, hot extremes at high humidity, and geomorphological extremes. Now, we've heard about all these subjects in this meeting. And I would, as one of the authors, I'm pleading for some assistance. And so I have two requests. One, that if you have relevant papers to these subjects, please send them either to me or to Shubin Zhang or Sonia Senavarante, who are the convening lead authors. And also, if you're interested, to sign up as a reviewer. These kind of IPCC chapters are only as good as the reviews we get. And is it still open for to sign up for reviews for this draft? For the first order draft, it's closed, but the second order draft, which will be much better anyway, will be in a few months. And so please help us.
Same will be true for the next workshop like this. It'll be much better. Let me pass that.
So I'm Nicole Carter. I work at the Congressional Research Service. We're an entity within the U.S. Library of Congress. So I'm much more on the informing decision makers. And so these are more like ideas. The war game comment really got me thinking.
Which one?
The war game comment really got me thinking about who does those and what kind of information might be available, and whether or not anybody here has actually participated or thought about participating in some of those. So, for instance, I I know at various times DHS and FEMA have war gamed on various types of natural disasters to identify, how to better improve coordination across the agencies and response activities. I don't know if it's something current. I know they had done it in the past. Similarly, DoD does that type of work, of course, as well as Department of State. I've seen do that within a water space. So it's just an ideas of if anybody has or tried or is maybe could think about doing that. And another entity or group I want to just mention, I've only participated in one event, but is the Worldwide Human Geography Data. I don't know if anybody works with them at all, but it's interesting as a sort of how I've seen them work is when there's a big event going on, they kind of call for data and people provide data and then share it. And it might be an interesting format for when there is one of these compound or sequential events to actually try to get some of that data and analyze some of that data as a group.
Yeah. Any more comments? Maybe especially like if some of the maybe younger voices in the room, if there's something, go outside the box. Is there something you wanted to hear about at this workshop that you didn't hear about? Is there something related to your own career path? Is something inspiring? Just wide open. Love to hear from somebody. Younger scholars who we haven't heard from much. Since of that, I think, and we'll have some kind of mechanism, I don't know what it is, to sort of capture more feedback at some point. We'll be in touch with everyone about that. So I think with that, we are now going to go, one more.
Yeah, your request for a comment now just had me thinking, if we're trying to keep communication going, I feel that the way our community, well, we're from a bunch of disparate communities, I suppose, but we could use things like Slack or something, We don't have to just email disconnectedly from each other. We can have communications that people can jump into and out of and see the records, and it might speed along research and collaboration.
That's a great idea, yeah. I guess with that, I was actually going to say something about sharing. Various people have mentioned to me, and we were thinking about doing it, but I suppose we definitely will now. First of all, sharing the slides. They're all visible on the recordings online, but of course, if you want to look at someone's actual presentation. So we'll sort of have an opt-out mechanism for that. But otherwise, we'll share the slides and posters as well. So we have we don't have most of the PDFs yet, but please send them. We'll email the poster presenters as a reminder about that. And then, about contact information, I suppose if there's interest, it can sort of be shared more, but we'll maybe gauge interest in a more formal way, since that's more personal, of course, even if it's just email. So with that, we had a lot of great early career researcher talks, and thanks to Nature Reviews Earth and Environment, we had to make the very difficult decision of who was going to win these things. And so we have one for talk and one for poster. So it was actually very close. I'm not just saying that, it actually was. We had a scoring system. So I guess if I say your name, please come up and we'll take a quick photo with you as requested by the journal. So best talk is Kai Coinhuber. All right, and then I didn't actually see her. So the best winner, best poster is Ariel Avgi. I'm not sure if I saw her or if she's here today, but if not, we'll applaud her anyway and give her a certificate later. And each person won a small monetary prize. So we'll be in touch with Kai and Ariel about that. Just a few other quick remarks before people come up and promote future platforms. As you all know, we had the remote presentations, of course, as well as the recording and the live stream and recording, and the recordings are all available online for the whole conference now. If you want to take a look at them. I got word from the video network staff that this morning, at least, we had a simultaneous count of 102 people watching the live stream. Wow. So almost as much as we have in the room. I suppose that qualifies as a success. And yeah, if if you're expecting reimbursement for travel support or something, we'll be in touch about that shortly. And then I guess I'll put up the photo that we took a few minutes ago, and I'll leave that up well, actually I won't leave that up because people are going to present some slides. So maybe let's do the slides first and then photo afterward. So maybe Olivia, do you want to come up first and show the other slide? Is Olivia here? Yeah.
So maybe just to make some advertisement again for the cost section in Europe. So every one of you who works in Europe and who would be interested in keeping being in a network and attending workshops or scientific exchanges can contact me, and we have these working groups and we have some funding for this, and this will run for the next nearly 4 years from now. And so in this cost section we already thought about we will have a final conference in 4 years, but we thought of having a kind of a midterm conference that could be maybe a follow-up of this event here. And so Olivia can show the Baron.
There's really not much more to say other than that tentatively it will take place in January 2021, and we'll make sure through the two of you that we have all of your contact information and can send out save the date emails as soon as it becomes more specific.
Okay, I want to make some advertisement for the Knowledge Action Network on Emergent Risk and Extreme Events. And we have heard a lot about correlated extremes and multiple hazards. And what we try to promote here is a global network that brings together the people like you in the room with interest in multi-hazard correlated extremes, but linked to the societal aspects. And this Knowledge Action Network is sponsored by 3 larger global programs. It's the Integrated Research for Disaster Risk, the Future Earth, and the World Climate Research Program. So what we're trying to do is to establish an interactive network linking these very different communities and having integration, co-development on aspects of emergent risks and extreme events. And we just we managed to have a development team now established with 12 people. Is it going further? And also, so we have the development team established, and the chair is Markus Reichstein, myself, and Felix Rieder are co-chairs. But what is the active part of this RISC-Con is basically these working groups, and we got a lot of application for different topics working on emergent risk and extreme events. And one overarching topic is compound events. So there will be a working group on compound events, and I guess everyone in this room would qualify to coordinate under this topic. And I know that Colin proposed also a working group. So we try to establish a platform where people on like worldwide could connect on similar topics that include not only the natural science aspects but social science aspect. And we welcome new ideas and partners. And what the aim is basically to provide links between these overarching agendas, global agendas like the Paris Agreement, the Sustainable Development Goals, and the Sendai Framework for Disaster Risks. And they're all interlinked and with the topic of risk. And correlated extreme and compound events, we have heard a lot about this, is one important element of this discussion. So I welcome you, stay tuned and contribute to this. It's, of course, it's non-funded, it's all voluntary, but our aim is, by connecting people, we also can find ways to have collective effort to prepare and participate in future calls, like Belmont Forum, which is a global research agency, but also European-wide. And so it's a way to keep us informed, to communicate, and we are just being basically set up or getting ready, so it's very new, and we welcome any contribution, and you can stay tuned or get new information about the development on the website. And yeah, that's right.
Anyone else want to announce any kind of similar conferences, consortia? Yeah, say a little about the proposed AGU session that Kai mentioned at the end of his talk. Just remind folks.
Oh, yeah, I was just going to say that Kai and I proposed an AGU session along with Bradley and Jakob about correlated extreme events. Essentially, it's pretty much just supposed to be a follow-on of this workshop, and sort of, like people mentioned, about the kind of inherently diverse crowd at these big international conferences. I think we're trying to sort of position ourselves within that wider set of people who attend AGU and EGU, in the future as well.
Is that under natural hazards? What's the,
Yes, I can't remember. I think something like that. Google correlated extreme events or something. Yeah, we submitted it 2 months ago and we haven't heard anything yet, but hopefully soon.
Alex has an event, I think.
Yeah.
Hanover, Germany. Sorry. It's in Hanover, Germany, organized by, I think, Volkswagen Stiftung and some others. Gosh, it's a long list. But anyway, it's in October 9th through 11th. Extreme events building climate resilient societies.
Any other events? Okay, we're coming towards the end of the program. I want to take a moment to give special thanks. I want to mention again our steering group for all the work they've done to help make this possible. And again, really special thanks to Adam and Susanna, who, as I mentioned in the opening remarks, really were instrumental in helping get this off the ground, getting so much advice along the way to how to pull up. And we hope you all feel was successful as it was last. And again, to thank Colin for all his remarkable work along the way. There's a whole other group that we haven't mentioned yet, and thank that it's so critical to how seamlessly this all works. We won't hold this group or anybody responsible for the fire alarm. Other than that, it was seamless. Pamela, thank you.
Yes. I'll put up our beautiful smiling faces to entertain you as you leave.